Hello, everyone. We are back with day 2 of Serverless Day Student Edition Conference. We had an amazing day 1, and thank you so much to all of the speakers and everyone who attended and participated in the discussions. It was a really awesome day. Today, we're really lucky because we're going to get a chance to listen to some of the students talk as well. Just as an overview, Serverless Day Student Edition Conference and just everything Serverless by Bit Project is an initiative dedicated to helping bring more students from non-traditional backgrounds into tech, into the web development and serverless industry. Our goal is to empower students to build, to learn, and to teach each other. If you want to know a little bit more about what we do here, you should go check out the recording from yesterday's conference. It's on our YouTube, and we'll also share it in our Discord. The serverless camp. So the 8-week bootcamp that we did leading up to this event is really just an opportunity for us to share all of our resources with a bunch of students. And out of them this year, we had 6 students who participated in our mentorship program. These students were paired up with industry professionals to learn how serverless works in the actual tech industry and build some really awesome projects with the help of their actual mentors. Today, you're going to get a chance to see all of the really cool projects that they built, their journeys in building them, how they came up with the ideas, how they decided which technologies to use, any challenges that they faced while building them. And we're really hoping that these talks help you decide what types of projects you want to build and encourage you to take that path on for yourself as well. So before those talks start, we're going to have a couple of workshops, a few more talks from our mentors. And yeah, we're really excited about today's schedule. Last but not least, we do have quite a few raffles going on. So you'll see those links being shared in our YouTube chat as well as in our Discord. So feel free to go ahead and check them out. There are deadlines. They do end at 5 p.m. today after the conference ends. So if you want to participate in them, go ahead and get started. And yeah, that's pretty much it. Up next, we have our actual mentor, Christian Lechner. He did a workshop with us about APIs. This is an API integration demo and debugging tutorial in which he basically gives anyone who has very little experience working with APIs literally a tutorial on how to get started, how to integrate REST APIs into your serverless projects, how to use the GitHub SDK and decode responses, and how to go about publishing blogs to Dev.to, which is the actual project that you built, directly from your GitHub. So it's a really awesome project, and I'm going to go ahead and get that started. Hi, everyone. My name is Shreya, and I am the founder of Bit Project, and I'm very lucky and excited to be here joined by Christian Lechner, who is one of our mentors for Bit Project and for our mentorship program. So hi, Christian. How are you doing today?
Hi, Shreya. I'm doing great. How are you?
Fantastic. I'm doing really good, too. I literally just woke up like 5-10 minutes ago, so I'm doing
Okay, for me, it's the end of a day and a week. So
Yeah, time zones are weird, man. Thank you so much. It is the end of week 6 or close to the end of week 6 for our students. So they're all working on our final projects. And I'm really excited to kind of be joined by you to work through this API workshop. Before we get into it, would you mind giving us a little introduction about yourself and who you are and why you care about mentorship in the first place? And then we'll just dive into the workshop.
yeah, sure. So where am I located? From time zone perspective, you could already guess it's probably Europe, so it's Germany. To be precise, it's in Bavaria, near a city there called Passau, which you might know or might not know. I'm working at SAP as a development architect in the area of the business technology platform, supporting the technology office of SAP, which has basically not that much to do with Azure at the moment. But I am really happy to share knowledge and to exchange with the community. And that's how I got into the Azure Functions University that you might be aware of. And over that way, I came to the Bit project because Mark Duker, who is the founder of the Azure Functions University, kind of pinged me and said that might be interesting for you. And yes, it is. So I'm really happy to support with this curriculum, which is, from my perspective, really a super good curriculum So absolutely kudos to all who have been involved and who are involved in that area, because I think that's really great stuff to learn, great stuff to start with. And I would have been happy if that would have existed 20 years ago.
Yeah. That's fair.
Yeah,
I mean, I'm really grateful to our mentor community, especially people like Mark, who are bringing amazing mentors like you to our team as well. And I'm really excited to see what this workshop is about. So could you tell us what our goal is for today? What are we learning?
Yeah, so with a little bit of delay, because your API week was week 2, which was kind of jeopardized due to a lightning striking my house and burning everything which was network related. We are taking a look at APIs and how to use them, how to find APIs, how to read the documentation, interpret the documentation, talking a bit about the, I wouldn't say best practices, but common practices around APIs. And I would like to pick up the things that have been discussed in week 1. So what was the point there was how do you present yourself to a possible employer? How do you tune your resume? And that was the discussion that GitHub is one point where you can present yourself. And that's true. So the idea now of today is, let's say you have a really cool project and you spend a lot of time and effort in there, and you have also a great README of that project. So in order to make life easy for those folks who take a look at that one. Now with GitHub, you can share the GitHub link, Twitter, LinkedIn, Polywork, whatsoever. But the interaction might be a bit difficult. So on GitHub, of course, you have discussions which are quite new. You have issues where you can interact with the community. But what you might also want to have in order to get a bit more spice into your resume, push that stuff to a blogging platform, right? So you can have likes, you can have, which would be stars on your GitHub repo, which are hard to catch. You can have interaction with that. You might get followers there and see what the community is thinking about your project. And at least from my experience, that's one important ingredient in order to spread the word what you're doing. So basically what we want to do today is we take a repository, we have a README in there, and we want to bring that out of GitHub into Dev.to, which is a blogging platform. I think BitProject is also using it. And we want to do that via an Azure function as, let's say, glue code between GitHub and Dev.to. So that will be the setup for today.
That is such an interesting use case. I love how it ties into all of the work that we're doing. And it's something very like any of the students that are working on could actually, like a need that anyone could actually have, which is fantastic. It's relatable, basically. Okay, let's dive into it. What do we need to, how do we start?
Okay, so then I will now, sorry, share my screen. Let's put away that. So I will not see anything. You have to shout out if something is not readable, is not visible to you.
We will yell at you aggressively.
Yeah, you scream at me. I will not see any faces or something like that. I will not see any chat. So I have to purely rely on the audio. Now, what you see now is the GitHub repository, which we want to take. It's a public big GitHub repository. It's a fantastic GitHub repository, of course, because it has Azure functions in it. And basically, it describes what we will do today. So we will take this project and the README file here and a bit of the description here and the title of the project or the name of the repository and push that into Dev.to. Now for that, we need a means to interact with GitHub and to interact with Dev.to. And for those who are following the curriculum, be it self-paced or as a one-on-one mentorship, That's what you have been doing. So you have been connecting bits and pieces via APIs throughout the course of the previous weeks within your functions. So you basically, it's not like Lego, but it's not that different. So you take the bits and pieces, bring them in the order in order to fulfill your business needs, so to say, and then get the hopefully expected result. Now, when it comes to interacting with systems, the first thing that you have to have is an API. And an API is an application programming interface. And basically, that's also the name of the game. So you have an application, and that offers an interface to the outside world where you can interact with the system or with the application. So it tells you what data can you read, can you manipulate the data, what types of data do you have within the system. So that's an essential ingredient in order to do those interactions. Now, usually you also have to do some stuff before you can interact, so authenticate yourself, which we'll see in a second. And when you are talking about APIs and the internet and GitHub or any other thing at the moment, you will end up saying, yeah, we have some REST APIs. Now, there I want to drop some words where this REST thingy comes from. And basically, you should see now a PhD thesis talking about architectural style and the design of network-based software architectures by a man called Roy Fielding from the year 2000. And he was the one who coined the term REST. So that's the representational state transfer, short REST, that was coined by him, that was first described by him. And what's important to understand is that's an architectural pattern. So that's how you define and how you design something that is not necessarily coupled to HTTP. Although HTTP as protocol of the web is very well fitting into that architectural pattern, you can also apply that to other communication protocols like gRPC. So it's not like REST and HTTP are interchangeable. REST is the architectural pattern, and HTTP is some kind of instance of that pattern, or very well fitting to the pattern. However, there are also some pitfalls that are common usage that are not that great from my perspective. I will point them out at a later section of today's session. Now, having said that, let's dig into what do we need. So basically, we need to read out data from GitHub. So if you Google for GitHub REST API, you will land at this page, and please tell me if letters are too small. You have.
Could we increase it by a couple? Yeah, that looks good.
So you have the REST API description, and what you see here, and that's quite typical, is you have basically the entities of the business domain that GitHub exposes. Now that's a quite sophisticated term for basically that's what you see when you interact with GitHub on the UI. So you have actions, you can take a look at billing, you create branches, you did that a lot. You can do commits via the API, and of course you can interact with the content of the repository. So when you dive through that, and I think it's very easy to digest, you will come to the point of repositories, and there you have, of course, a lot more subtopics there. And I already looked at the Get a Repository API. And that's also quite, let's say, typical way how to present an API. So basically, you have a short description of the API. You have the parameters, so how to interact with the API. So what's requested from you in order to make a successful call. Like here, you need to hand over the owner and the repository. And you have the endpoint that you address. And you, of course, when it's HTTP, you have the HTTP verb that you need to use in order to interact with the endpoint. In addition, you have examples. That's optional, but usually that's in there. So at least you usually have a curl example, which is quite helpful in order to see how the parameters have to be filled. So you can see here we need probably a header. We need an authorization via a token. So basically we need to authenticate. And we need to pass in the URL. What's cool here, we also have an JavaScript part, which looks a bit different. And the reason for that is if a company is heavily relying on the interaction via REST, it usually makes the life for the developers easier and offers software development kits, so SDKs. And OctoKit, which is the natural name for the SDK for GitHub, which has the OctoCat in there, offers exactly such an SDK. And what I also like about that SDK, it does not hide everything from you. So it's quite clear what you do, but it helps you, for example, because here you do not need to take care about the accept a header. So that's just something that is done automatically. Now, what's also part of the description of the API is usually some examples. Like here for a successful request, where you can then scroll through and see what should come back, and there comes back a lot. Then with GitHub, there is one special thing in there which is called response schema. So maybe you came across that. That helps you a lot when interacting with JSON. It's a so-called JSON schema, which allows you to validate your JSON files. So usually JSON is completely freestyle, but with JSON schemas, you can define how the structure of a JSON file looks like, and GitHub is so kind to provide some. And then you have, of course, a response, because that's why you make the call, right? With several status codes. So here we have 200, which is okay. And we have then specific HTTP codes, which represent situations that could happen. So maybe you're not authenticated, then it's forbidden. Maybe you wanted to fetch a repository that's not existing, then the resource is not found. Now, this is exactly one point where, from my perspective, it's debatable to say that's a REST interface, because these are the status codes of the transfer protocol, which is HTTP. If GitHub would switch to gRPC for some reason, or add gRPC support, they would have to add additional status codes, because gRPC has no HTTP status codes. So that's kind of, from my perspective, a bit of a weak point when bringing REST into HTTP to or abuse, I would say, the HTTP status codes for error messages that has nothing to do with the technical transfer. But that's what you will always see, and that's what you will always have with those APIs. So you have to deal with it. If you design an API yourself, maybe you could do something different. We won't do in today's session, but just to bring it into your head. So that's one API that we will use. We will also use another API, which is the get a repository README, which is also, I think, a quite logical structure. So you get the README from the owner of the repo. And then when we have the data, we need to push that to Dev.to. And the documentation for the Dev.to API is a bit hidden. So it's under developers.forum.com. And you can see here the documentation, which gives you some general guideline, and also makes you aware that it's not yet for productive use. So it's in beta state, so things might change, things might break. I did not recognize that over the last couple of months, but be aware of that if you are playing with the API. And we have here the API, where you can also download a specification. So that's now a so-called Open API specification, which describes the structure of the API, which is basically exactly what you see here. So this UI that you see is based on this Open API specification. You might also read the term Swagger specification for that. That was kind of the predecessor of Open API. And yeah, this API we will use in order to publish an article. So as you can see here already, it looks similar to the one of GitHub. So we have some description here. We have some additional information that there are rate limits. And we see we need an authorization via an API key, which is the usual way. And then we have some object that we have to hand over. That's how it looks like. And then we have different responses, like 201 when an article is created, and all the other ones when that could happen in the error case. Yeah, that's basically all the ingredients that we need. In addition, and that's nothing that I will show, is you need to fetch an API key. You can do that via your Dev.to user. So if you go to dashboard, to your settings, then you can fetch an API key there. For GitHub, you have to go to your GitHub settings and navigate to your developer settings, and then you can fetch a personal access token that you will need in order to access the GitHub APIs. The only exception up to now is public repositories and read activities. So you can read quite some data from public repositories without authenticating, but you might not get all the data. So that's something that you have to keep in mind. And now with all that blah, blah, let's start the coding. I will keep that open as a fallback if I'm not sure about some code snippets or I'm just too lazy to type. So what we will do now is we will create a function.
Okay, right before you get into that, just want to remind students that Christian is building this project and he's going to try to cover as much information as possible. But if you have any questions about what he's saying, any specific concept that he mentions that doesn't make sense, or even if he explains something and you want more detail on it, he is like a genius. So just feel free to ask and he will let you know. I will be here to just read out your comments and stuff. So you can either ask in the Twitch/YouTube chat, or you can ask on the Slido where it's anonymous if you prefer that. And yeah, go ahead, Christian.
Good that there's no pressure from your side.
Yeah.
So we will create a JavaScript function. We will do an HTTP trigger there. We will call it blog post publisher. I mean, basically that's something that you already know by heart if you have done this training. And then you have the classical layout. Nobody needs that sample.dat data of your function project. And we will basically quite start from a clean slate. What we want to have is, of course, a response at some point in time where we will put in a response status, which might be different depending on what we achieve. So we will have a response status, which is, we defaulted to 200 because we're optimistic. And we will have a response message, which is empty. Okay, so that's point 1. And well, then what do we want to have? How should we structure it? So let's create a file called request.http, which is a very specific file. I'm using an extension here called REST client. It's this first one, which allows you to do REST requests or HTTP requests via such a file. I like that very much in contrast to Postman, but that's of course personal preferences. So what we will have is something like a local host.
Really quick, why do you prefer using the REST client over something like Postman or Insomnia?
Yeah, the reason for that is that with this file and all the requests being in the same repository as the code, I have that under source control, and I can push it into the GitHub repository, and everything is code. With Postman, you can, of course, also create the files that contain your requests, but you have an additional tool to open. You have to deal with an additional tool. You have to switch windows. I personally do not like that very much. I like to keep things, let's say, self-contained or things together, and that's why I really like that one. And from the perspective of power, it's as powerful as Postman. So you can do consequent requests and use the response of request 1 and request 2. So there is no downside. At least I did not find any with respect or compared to Postman.
Yeah, I completely
But
agree. Go ahead.
it's absolutely personal flavor. If you like Postman, if you have been working a lot with Postman, go ahead.
Yeah. And if you're curious about what Postman is and what the REST client is and what purpose it serves, what is could you give us like a brief understanding of that?
So I had a short. Did you ask me something? Was there a
Sorry,
question?
yeah.
Or?
I was asking what the purpose
Okay.
of things are,
What,
like REST
what the
client.
things are? Yeah. If you want to interact with the endpoints of a REST of a system that exposes those REST APIs, you need to have some tooling. So of course you can use the browser, because basically what it does in the backend is also doing requests, but you have a very hard time to do post requests there, for example. And in order to execute those requests, in order to parameterize those requests, so what do I hand over to the request? That's where those tools come in quite handy. And you can also structure your requests in there. So for example, within Postman, you have collections where you can collect your settings, and you can very easily combine the requests as you can do them here with respect to doing the authentication and then fetching the information necessary for a follow-up call. So that's where these tools play their big role. So it's mainly about interacting with HTTP endpoints.
Yeah. Awesome. Thank you.
Okay, so that's good. It already remembered that one from some dry runs. So we have usually with Azure Functions this endpoint, and now it's really open to you how you want to hand over the data. So maybe one could think about doing that via query parameters. One could do that in the body. One could do that as an array in the body if I want to publish more than one blog post at a time. We will now, for the sake of this demo, use the body of the HTTP request. And what we basically want to do is we want to say, I have a repo owner, which would be me. And I have a repo name, which would probably be, and I've got again that one, which will be this one. And I want to call the Azure function, hand over that information, and then publish the blog post somewhere. So that would be the idea. Now, in order to do that, within the function, what I will do is, first of all, validate that those two parameters are in there. So I will check if I have a body transferred when the call arrives. So as you can see here, we get the request into our function. And then I also want to see that the body has something like a repo owner in it. And I also want to see that the request has a repo name, because that's what I need. If that is not the case, and if I could type. I want to say response status equals 400, which is basically means the caller has something done wrong. And I want to hand in a response message, which says, please provide the repo name and owner in the body of the post request. So if we are not lucky, we get an error message. If we did everything wrong, everything right, we will end up in the if clause. Now I will transfer that to some local parameters. So I want to have the repo name so that I do not have to reference everything every time. And I will take the repo owner also as a local parameter. Now that's, again, a question of how you want to do things. I prefer to have that as a variable.
We have a quick question about why we're adding these two variables into this file.
That's just a question of let's say, personal style. So you can always within the code dereference that JSON object. However, from my perspective, I think it's more readable at a later point in time to just see repo name, because then I know that's the repository name instead of reading, okay, that's the request, that's the body of the request, and within the body of the request, I have a repo name, which is basically the repo name. So it's just, it's exaggerated to say that that's a mental overload, but I think it makes it more readable and makes it easier to understand if you have those two, well, shortcuts, abbreviations for those parameters of the body.
Yeah.
But as I said, it's nothing wrong to use that directly.
Makes sense.
Okay, then what we want to do is we want to call the GitHub REST API, right? We want to get the information from GitHub. Now, let's put that over here, make it bigger. We want to get the repository. So basically what we can do is we can first copy that over. So we have an OctaKit. We have to hand over an access token that we do not have yet. So we have a GitHub API, GitHub API key that we will fetch in a second. So we will hand that over here. And then we do this call here where we now hand over the repo owner as well as the repo name. Now, what do we have to do in order to do that, to be able to do that? Well, of course, we need to get the OctaKit SDK. And as you can see here, that's really cool. They have the URL right here. So we should see some example here.
What is the difference between an SDK and an API?
An SDK is basically some pieces of code that wrap some functionality for you. So this can be, let's say, some mathematical functions that where you don't want to implement the algorithm, and they kind of wrap them for you and make them easier to access for you. So that's an SDK. An API is an interface where you interact with a system, with an application. So it's a bit fuzzy to understand, but with an API, you just have, let's say, an endpoint, an URL that you call. And with an SDK, you have a complete, in this case for JavaScript, a node module that contains a lot of functionality that you can put into your code and use it within your code. So that's kind of the way how I would coin it.
That makes sense.
I hope that answers the question.
Yeah, I don't know if my example is going to make it more difficult to understand or hopefully easier to understand, but even for the Courier, we have an API. Courier is an API, and you can use post requests to interact with it. You have an endpoint, you have an API key, all of those things, but you can also choose to install an NPM package, which is our Courier SDK. And if you do that, you don't have to make a request, but you still end up doing like the same type of functionality. So it's not like they're two completely different things. It's just the way that you interact with those different softwares.
Yep. So it's more about convenience. So we will see later that for Dev.to we do not have an SDK. So then we need to use a different functionality.
Gotcha.
So that's what we need to put into the code. Then we need, of course, to install that. So we need an npm I and an OctoKit core. So that should now download the internet, and then we are good. So we should see now that we have a node modules folder, exactly. So we have now that put into our project. What is open now is where do I get the key? So as I said before, I will not show you keys, just because we had some experience with that on prior live streams where there are some clever folks who look at Twitter and then use the key. But I will just take the one that I have downloaded before, and I put that in my local settings.json. That's kind of the best practice, that to put that stuff in the local settings.json. Why? Because it's not getting committed. It's excluded from your Git by default. And that's the place where you can access your environment variables then. You do not have to change your code once you have that and put those in Azure in your application settings. So that's also a big advantage. So what I will do now is I will take that one, move that over, replace it. Yes. And that was that. Now I have to quickly do a glimpse how I called them. It was those twos. So what I will do now is I will, of course, fetch those. I make that now a bit bigger in my code. So don't get nervous by me doing copy pasting, which looks not reasonable at the first point in time. So I will put in the GitHub key, and I will also put in the Dev.to API key, because we need it anyway at a later point in time. Okay, so we have now the keys. We have the OctoKit SDK. We make the first request. We also, so here we get the information about the repository. We also need to get the information from the README, as we have seen before. And here I will just copy this code snippet and put it here. So as you can see here, it's a bit of a different endpoint that is targeted. So it's not a README endpoint, but I can, of course, reuse the other variables because that did not change. By the way, it's also a question of your personal preferences. If you put in the semicolon or not, JavaScript will not care about that. But be consistent. That's something that's important. Now we make the call. Maybe we also want to get the result in a way that we can use it. So I would say we have here the repo metadata, which we get from here, and we get the repo readme, and we will later see that that's in a special way how we get it. We get it decoded, encoded. And with that, we can now check if the call was successful. That's what we would do first, right? So we would see, did we succeed? And in order to do so, we can check the status. And jumping back to the documentation, we have read requests. So I would expect the status to be 200 if everything's okay. So that's true. So what I will do now is check if the status is 200. What I will do now is something that I would say don't do at home. I will check both statuses in one line. And we will in a second see what's the downside of that. Namely, when we have to deal with the error case. So if the call was not successful, I, of course, want to return something reasonable. And now the question is which call went wrong and which status then is the one to hand back, or did both go wrong and they have different statuses. So usually you would do this stuff for every call. Now for the sake of time, I will basically just hand back one status, which is 500, something went wrong on our side. And then I will do something like the calls to GitHub did not succeed. Status of metadata is we have the repo metadata status and status of readme is the other one, right? So we have repo readme encoded status. Yep. So that's how we would do it. It also makes sense to of course add a log message there if you're running it on Azure, but also if you want to run it here on the terminal. So we will also make our life easy here. We just hand over the response message. And I say that's the thing. If you would do something like that in a real world application, you would probably define some schema for your response messages that you log, for the messages that you log, to be precise, because you want to analyze them automatically, and you do not want to have to think about how they are structured. So you would usually have some response message which says status dash message dash error code whatsoever. Yeah, with that, we are already not too bad, right? So what we can do now is we can check if we get something back. So I will start the debugger, which is just pressing F5, thanks to the work of the Azure Functions creators, because we have the launch configuration already there. Now, what usually does not work is the first debugging run. Ooh, it works. Okay, cool. Usually, you might get some error messages which come from somewhere deep within the Azure Functions runtime. Don't get nervous if you do the debugging for the very, very first time of your Azure function. Abort the debugging and start it again, because there was just some hiccup when doing the very first initialization of your project. So now we have the endpoint. We can now make the call. I think I did not make any typo, so we can send the request. and then we can step through it. So we get the OctoKit SDK, we do the request, the first one, we do the second one. So at least we did not mess up anything severe, so no exception was raised. And now let's see, we have, I should have put status in here, right? Let's see. Also here we have the status 200. So now it would jump into the error message because I just forgot to put in the status here. But that looks not too shabby. So let's run it. So I would now get 500, of course, because I forgot to code it the right way. But we are on a good path. Let's do it again. To see that we are good. So I think that breakpoint is then sufficient. We will send the request. We hit it here. So we have status 200, we have status 200, and now we are also fetching it. And now let's take a look at this little guy here. So we have the repo readme encoded, which is a JavaScript object. We have the data in here. And we see that we have an encoding with base 64, and we see that we have the content which does not look readable, at least not for me. And yeah, we have some more information in here, which is handed back, like the name of the file, the path to the file with respect to the root of the repository. And the same is true for the repo metadata response. So again, we have here a data object within the repo metadata, which gives us back a lot of information that we want to know or do not want to know. So we have here something like the description that we will use for the blog post, and a lot of other information. So that's all looking good. Why do we have a breakpoint there? That makes no sense. So now we are fine. Okay, then what do we have to do next? We now have fetched the information. So basically what we want to do is we want to create the article, right? For Dev.to. And we want to publish the article. So that's kind of the idea that we want to do. Now, we just saw that the README was encoded. So we first need to decode that stuff in order to have a readable content of our blog post. So what I will do is I will put in repo README, or I would just say README decoded. And for that, we use the buffer from method, and that one takes two parameters. It first of all takes the encoded source, which is the repo readme encoded data, and it was content. And then I want to have the repo readme encoded data and the encoding. So it's base 64 according to the documentation, but if they change something, that will be resilient to that. And then I want to do that to a string, and I want to have UTF-8 output. So if I did not make anything wrong, we will have the UTF-8 string of the README in this parameter. And then we have to create the object that we hand over to Dev.to. So let's shortly jump back to the API description. We want to create a new article. And in order to create that article, we need to have an article object well, which contains of a title, makes sense, of a body, which is Markdown, also makes sense. We have that already. Then we want to say if we publish it at once or if we want to store it in a draft state so that we can see it, but nobody else can see it. Series is something specific to Dev.to, so you can link several blog posts together. We can hand in an image description. We can hand in tags, which is cool. We are no organization, so basically we need to build something like that. And well, let's do that. So what we will do now is we will create a Dev.to article. And in order to do so, we will call a function, which will build us the Dev.to article. And here we hand over the repo metadata data object, which contains all the information about our repository, where we can drag out the title and the description. And the README decoded would also be great to have that. And with that, let's do function, which let's just copy that to avoid typos. Say that's the README repo data. And now I will do a little bit of a shortcut because that's just typing things around. Let's see. Where do we have it? Here. So let's just copy that and put that in here. So what do I do here? I say I define a Dev.to article, which has the structure as needed in order to call the endpoint, which is an object, a JSON object, which is an article, and which has another object contained in there. So I have to do some stuff here. So it's a repo metadata, README decoded. Looks like that. We have the tags, which I have pre-filled. So I think we can do 4 tags. So we can also put in bit project in here. I will not publish it at once, and I will put in an image as a surprise. What's on the image? And then I return that JSON object back to the caller. And now we can do our call to Dev.to. Now, this is also something that should be described somewhere, right? Because we would like to do the call. Now, as you can see here, we do not get any information about the get, or I'm just missing it. So maybe that's due to the sizing. So now you basically will see not too much. But now you can see that we have here on the right-hand side this post. Or at least you can imagine that there is a post. And we can now see how do we do the call. So we now have really to call an HTTP endpoint, which we can see here. So that would be the URL that we have to call. And then we have to hand over a content type, which is JSON. We have to hand over the API key also via the header. We have to do a post because we want to create it. And we have to hand over the object. So that sounds reasonable. And we will then hopefully get back a 201, which is usual for creating something. Yeah, so then let's see if we can do that. So we say the Dev.to endpoint is the one that I just copied. And then we have to make the call to this endpoint. So we say we have a Dev.to response, which is a wait to the famous fetch library that you basically have used now, I think, for a lot of times. So we have to install the fetch API. So npm I node fetch, and we have to install version 2 in order to be consistent with the common JS modules that we use. Otherwise, we would have an error here, and then we have to import it. So we say const fetch is require to node fetch. And now there is one thing that I do besides making typos. I will pin the versions. So usually when you do an npm install, it will put in that little symbol here so that the version gets updated with respect to semantic versioning. So if there is an update of the, I think, the minor version or the bug fix version, which is this one and this one, it will install a newer version if you do an npm install. And I don't want that. I tested with that, with those dependencies, and I want to use it with those dependencies. So what I will shortly do is delete the package.json and do another npmi. Now that's something, when you ask yourself, why the heck does this guy do that? It's just to be safe, to use the versions that I used when implementing the functionality at a later point in time. If I push that to a repository, even if there is a package log.json in there, and you would clone it and would do an npm install, and there is a later version in there, which might be 4.1.4 or 4.0.6, it will install that one if I still have this symbol in there. If I do it like that, you will use the same version that I did. With that detour to package management in Node, what do we have to do now? We have the, no, not the key. I want to have, of course, the endpoint here, Dev.to endpoint that I want to address. And then, sorry for that, I have to put in some data. And again, as I'm really lazy, so I have to put in the method, which is post. I have to put in the right header, which we'll see in a second, and the body. And again, let's do a little shortcut here. And just copy that. So, shouldn't that be that? No, shouldn't. As you have been working with fetch, I think I do not have to explain too much there. We hand over the method, which is post, as we saw in the description of the API. We hand over the headers, which contain the API key, which we have called Dev.to API key. That's good. Then we have to specify the content type. That's something that Dev.to wants us to do according to the documentation. And then we hand over the body that we have to stringify from our JSON object. So it's not the Java object that we have, JavaScript object that we hand over, but the string that represents that object. And with that, we can do the call. And then we have the same procedure as every call, so to say. We have to check if we messed something up, and in this case, if I messed something up or not. So we have to do the Dev.to response and check the status, and we have to check this time for 201 because we created something. If this did not succeed, we will just hand over the Dev.to response status and say publishing to Dev.to field. Publishing to Dev.to field. We have a status, which would then be, in this case, the Dev.to response status. And there's also some additional information contained in the Dev.to response, in the fetch response. So we have that into the Dev.to response,
I'm just popping in real quick because we have a question that's asked, what is a good practice to read documentation? This person said that they're kind of overwhelmed with a lot of documentation out there. Do you have any tips?
What is a good way to read documentation? So first of all, if you are overwhelmed with documentation, then that might also be that the documentation is not good. So it's not always to search for the error on your hand. So it depends a bit on how you do your learning, how you do your studying. That there are different approaches there. So what I usually do, let's say if we have Azure Functions. And of course, you see that I'm in Germany. So usually, as far as I know, where Microsoft is definitely a role model when it comes to documentation, but there is also good documentation at Azure sites. I think Courier also has a quite neat documentation of their APIs on how to deal with them. You usually have some quick starts. So how do I approach a new topic when I need to read the documentation or dig into the documentation? What I first do is I take a look at the quick starts and try them out, just in order to get some hands-on experience how things behave. Now, if I have done that, and I want to have some more in-depth experience with it, I either go to something that is contained, that there are always some samples, either directly in the documentation or somewhere on the GitHub or GitLab, depending on the company, where you find some more code examples that helps me to understand a bit deeper how things are working. So I'm more learning by example than learning by the abstract documentation and first reading the abstract documentation. When I think I have some basic grip on the stuff that I want to know, I then go to the concepts or to the, I think that's in the concepts area usually, on the topic that I want to know more. So let's say I have started with Azure Functions. I have tried out my first quick start with an HTTP function. I might have done now a function with blob storage. And now I want to know how this triggering really works, because I saw this HTTP trigger works out of dark magic. I will look up in the documentation exactly that area and then dive into that one. So what I'm trying to explain, hopefully, is start somewhere where you feel comfortable and where you can get a bit of hands-on experience, and then expand from there the way how you dig into the topic, and build kind of a network from the point where you started. So jump to okay, I want to know about triggers and bindings. Okay, I have understood that now. Now I want to understand how is the scaling done for Azure Functions. So I will take a look at that next. And maybe then I have some questions. Well, how is it best to do error handling? Because I'm running into errors and I somehow deal with them, but how can I do that? Then I jump into that section. That's how I personally would do it. If you are a very, let's say, a person that likes to start with a lot of theory and then wants to dive into the hands-on part, I would then start with the concepts or maybe also the references to wrap your head around that and then start with the examples. But that's quite hard for me to give an example because that's not the way I would learn it. Now, when you say overwhelmed, I'm now an old guy, been in IT now for 17 years. And be assured, I'm also overwhelmed by information, by documentation, and by learning things. Maybe that's due to my age because I'm old and forgetting things very fast. But maybe that's just because things are evolving very fast. So don't get frustrated and don't get demotivated by that. Start at one point and take it from there. You will not find many people. There will be the rare exception who know about everything. You start somewhere and then you expand your knowledge and you get an expert in some area. You might get some insights in another area, but you will not know everything in depth in every area. So that's just an illusion. So start somewhere, expand, grow, and try to get an expert in some area, but don't try to get an expert in every area because you probably will fail. And as I said, it's always overwhelming. So if you, for example, start with Kubernetes, which also has a great documentation, by the way, which is a completely different topic, you will be, super overwhelmed by the documentation and by the concepts. But as you can see here, there is also getting started. So try to get started, try to do some tutorials, try to learn the basics. And as you can see here, the structure is not that different for a lot of documentations. And then once you have, for example, done step one, then maybe dive a bit more into the depth, what's behind that, and then go back and try the next step and take it that way in an iterative manner. So don't try to eat the elephant in one bite, but take it bit by bit.
I just want to add to that really quick. If you are working with documentation and you find yourself a little confused, don't try to use the documentation as like a single source of information. Definitely Google things, check out other like online communities. There's a lot of developers that'll explain concepts that are in docs on other websites. So if you're stuck and you're not understanding something, don't just like give up on yourself. It'll take time. It's a very relatable struggle to deal with documentation and everything.
So as I said, there is also bad documentation. So it needn't to be your fault if you struggle with the documentation. Maybe the documentation is crappy. And as Shreya said, there are more sources than just the documentation. What I think is really valuable is YouTube. So you have a lot of tutorials, a lot of great people sharing their knowledge there and explaining different parts, be it Node.js, be it Azure Functions, be it I don't know what. And that's really something where you can also wrap your head around that because you can follow along at your own pace, take a look at the video, bring it back to the point where you lost the connection or the understanding, and then continue from there. So that's all perfect, and don't get discouraged, and don't get doubts about yourself because you just did not understand the documentation from A to Z. I don't do, and I'm not that frustrated. And Shreya and I made a video not too long ago, and we basically struggled 1 hour to call an API endpoint. So that's also something. Even we had the documentation there, which was crap. So that's kind of usual, so to say. Also, it's a bit frustrating at the point in time when you do it, but on the next day, maybe it works.
Yeah, exactly.
Right.
Exactly. It was embarrassing, but we got it at the end of the day, or after a few days. But I also want to add, right now you're in your learning stages, so don't focus too much about like, I just need to get this project working. I'd recommend putting the focus on like, do I understand what's happening, regardless of whether it works or not? Because sometimes technology just doesn't work out with you. But as long as you have a deep understanding of why things are or aren't working, that's good. And when you're reading through documentation, try to imagine it as like a, would I be able to explain this to someone else? And if you can, that's great. But if you feel like you're talking about it and you're using terminology that you don't even completely understand, again, like definitely make sure you understand all of those concepts before you try to integrate these technologies into your own projects, because learning is a lot more important at this stage than just getting your project to work. But yeah, I'll let Christian take over again.
Absolutely. And if you have questions, I mean, we have Piazza, we have Discord. So don't shy back from asking questions. That's what the mentors are for, to answer you and to support you. So now I will just take that code before I forget it. No, I didn't want to take that code. It was Dev.to response status and status text. That's the one that we wanted. So if something fails, we hand back the status and we say that was the status text that the HTTP call returned. And then we, for the sake of time, as we are already quite over an hour, I will just copy that. Nope, that didn't work. Okay, so what did we do? We fetched the response from the Dev.to endpoint where we published our blog post, hopefully successfully. We checked what the response status was. So if it's 201, which means we have created our blog post successfully, what we will do is, and you have done that now probably 1,000 times, transfer the response to a JSON object so that we get the body in a handable format, and then we will hand back a response, which is the status, and some nice response message. Now, when publishing something to Dev.to in draft mode that we did, so sorry for that, I think I forgot to mention that. We put that into draft mode, so we will not publish it. You will get back an URL by Dev.to, but that will point to a dead end. So you have to go to the dashboard there, and then we will hand back the response message. In case we did not succeed, we tell the caller we have made an error, and we cannot do anything else than just handing back that error. And with that, we can give it another try, I would say. So let's save it. That's important. And let's see how things work. So nothing wrong here. Except for one thing. Let me shortly abort it. We want to create something, so we definitely only want to support the post endpoint. That's something that you have to do or can do in the function.json file of your function. Which HTTP methods do you want to support? And for that function, I only want to support the post method. That makes sense. Making the tension unbearable if things work. So at least the function starts up. We have a host log, that's good. We will send the request. That was where we were before. So now we have the content, we have the encoding, base 64. So let's jump over. Oh, that looks better, right? That looks like human readable. Then we will build the article with our own little function where we have now the article. We have everything in there. That looks nice. We have the endpoint, and then we make our post call to the endpoint with the article. And let's see what happens. Yippee, status 201. That worked. So we can now just walk it through. And we will see, okay, we have the response that we got before. We have the blog post published at Dev.to. Check let's do it that way, check it on the dashboard. That's exactly what we wanted to see. So let's see what happened. We have Dev.to. I will open my dashboard. And we have our post in draft state. And we have the right picture on top. We have the Serverless bit project camp. Usually struggling with the sizing of the picture. We have our information here with the tags, and we have all the information that we stored in our README now as a blog post that we can share, which is also maybe a bit nicer to read than just the README. And we have all the options there within it's a long one, within the blogging platform to start discussions, to see if people would like to interact with that and so on. And we can also get some statistics out there. How often was it read and so on once we have published that. Now, let's try to republish it and see what happens there, just for the sake of having some fun with debugging. So I will put a breakpoint in here. I will do the same request again. And I will try to do it again. And now let's see what happens. We have a 422, okay. So it was not published. And it tells me it's an unprocessable entity. Okay, so I have a 422, everything is okay. Looks, well, it's okay because I published it, but I would like to know why was that. And that's basically one error that you get back, and that's a fair error because it's described within the page. So I'll make it a bit larger, which means that your blog post is already existing. So you have it on your Dev.to already, and you cannot just create it again because it was already created. So what we would have to do in order to update it, we would have to do a put on the article with an ID XYZ in order to update it. So that's now also how you can dive into the documentation. You get an error code, you look at the error code, and then you have to reflect a bit. Post means create, usually in HTTP. So it's already created. Put means update. So I would have to use a different method in order to do that. Yeah, and with that, we are at the end of the session with respect to the coding. As you saw, all the code is available on my GitHub repo. It might deviate a bit from what I've done in the live stream because usually you name things differently. But you can take a look at that repository if you want to check the code or if you want to clone it and use it.
Awesome.
That's all possible.
So we have one question, and if y'all have any other questions while we're talking, please feel free to drop them either in the chat or in the Slido. But the one question that we did have, let me find it real quick, was how do you include some aspects of security in this API?
So you mean in the API that I have exposed, or
yeah.
Okay. So with Azure Functions, I have to share the screen again. So with Azure Functions, basically the built-in functionality is a bit limited. So what you have is you have this authentication level, which could be anonymous or function. There is also a third option, which I have never used. I think it's administrator or something like that. Basically, what it does is anonymous says it exposes an endpoint which is completely publicly available. So if you know the endpoint, you can call it and it will be processed. As a first level of defense, so to say, you can put in auth level equals function, which means when you deploy the function to Azure, you will have a function key or an API key. So basically, it's the same functionality as we have used here. So, and from the start, only you know the API key. So only you can call that endpoint. If you spread that API key, well, everybody who knows that API key can call it. But of course, you can change the API key. And if you see misuse or something like that, and then you can create a new API key. That would be kind of one way how to do it, how to authenticate calls. And as you have seen here with the Dev.to key, I don't know if you wondered about that. I called the endpoint with an article that I want to publish. And within the article, there was absolutely no information for whom I want to publish that. So maybe I wanted to publish for Shreya. That's not possible, at least not with my API key, because this one is personalized for Dev.to. So I create the Dev.to API key, and Dev.to then checks the API key. Is it a valid key? Okay, then somebody is allowed to do the call. And who does this key belong to? Because this key only allows me to do interactions with all the content that I have published, and not the content that Bit Project has published. And the same is true for the GitHub API key. It's not that obvious at a first glance. With the GitHub API key, I mean, we can shortly take a look to see what's different there. It's here under developer settings, so it's variable hidden. And here you have the PATs, the personal access tokens that you can create. And you can generate a token. And of course, I need to enter a password. And there are some measures of security for those API tokens that you have to think about. One is expiration. So with Azure Functions, the key that you create when you set the authentication to function does basically never expire, which is not the best practice, let's say it that way. So usually you would enforce those tokens to expire and do a refresh after several amount of days. And then a second point that is specific to those access tokens for GitHub is you can specify what the functionality that uses the token is allowed to do. So it's not only about authentication, so telling GitHub, I am Christian Lechner, I have this token. It's also about what am I authorized to do? So what am I allowed to do? For example, am I allowed to update GitHub Action workflows? Well, if I just want to do a read of a repo, probably not. Should I be allowed to, I don't know, we certainly have somewhere a delete the repo, yeah? Well, if I just want to read a repo, basically I will not tick that checkbox. So you can narrow down the access rights that you have with such a token. And again, GitHub is here a quite good example of how you can do that, and how you see how granular you can do that. So that the level of granularity is quite high. Coming back to your question with respect to the functions API, so usually you would not just deploy your function and expose the function endpoint directly, but you would probably, let me shortly take a bit of water. You would probably put something in front of your function endpoint, which might be an API gateway, or some web application firewall, some things that would save you from, let's say, DDoS attacks, so distributed denial of service attacks, when a lot of folks try to hit the endpoint and want to try out when it comes down. Or you would use an API gateway in order to do some throttling, for example. So as we saw here, you can then check, maybe somebody wants to do a lot of requests and you say, hey, sorry, but within a minute you only are allowed to do 45 requests, and that's nothing that is built in within Azure Functions, and that's for a good reason. You have to plug in an additional functionality within Azure, and you have that with API management or an API gateway in order to make that reality. So when you really want to do that on a, let's say, professional, so don't get me wrong, professional level, production grade level, how you would do it in real enterprise software, then you will put something in front of your function in order to secure it with respect to attacks, and also with respect to who is allowed to call it. So you would have such a token, and probably you would also have some additional information then on, I don't know if that was shown in the session about Azure Static Web Apps by Anthony. You can authenticate, for example, you can use Azure Active Directory to authenticate to get some more information about you, and then use the information that is there in order to guide the processing and secure your endpoints. So that's all possible, but that's very different and well, difficult topic. And there are a lot of ways how to do that. It also depends on what you want to achieve, but there are a lot of options, and that's, from my perspective, really a field of its own to be there really an expert and get all the right knobs into place in order to have a secure endpoint.
Awesome. Thank you so much, Christian. I don't think we have any other questions right now. But for the students, if you do ever have questions about this, like Christian mentioned earlier, feel free to ask them to our mentors via Piazza, or talk to your one-on-one mentors on Discord. And yeah, you can reach out to us on any of our social media platforms. But yeah, thank you so much, Christian, for this workshop. Sure. I think it was really valuable.
Yeah, awesome. That was an amazing workshop by Christian on how to publish a GitHub README to Dev.to. I especially love how Christian, when you walk through the strategies to not only read documentation, but also when you walk through the errors that you were getting with us and how you debug them by yourself and in your practice. So our next talk will be from Ryan Cormack, and his talk will be on TypeScript Beyond the Stack with the CDK. And Ryan has worked with AWS technologies for 10 years and is currently working with Moonpig on their Tech Foundations team after helping other technologies teams build on serverless platform across multiple brands and countries. So let's get started creating a full stack TypeScript application with the AWS Cloud Developer Kit.
Hi everyone, I'm Ryan, Principal Software Engineer at Moonpig, based in London in the UK. I've been using AWS technologies for around 10 years and almost exclusively with their serverless services for the last 5. So today I'll be talking a bit about how and why we use infrastructure as code, a bit about the AWS CDK or Cloud Development Kit, and then we'll take a look at how we can leverage the CDK to allow us to deploy a fully serverless web application with a front end, back end and infrastructure all in TypeScript. We'll use React on the front end, and AWS Lambda functions written in TypeScript in the back end, along with an API gateway. And then we'll have our serverless DynamoDB database being our data store. Again, we'll define all of this infrastructure in TypeScript. Then finally, we'll look at how we can actually deploy the application to AWS using the CDK. And then we'll have a look at some of the things that you should consider if you were to go about using the CDK. So, first, what is infrastructure as code? Infrastructure as code, or IAC, is the concept of defining your infrastructure. It could be a server, a database, right the way through to the cloud-first serverless resources we use today, like AWS Lambda and DynamoDB, in some form of language or configuration file. This could be a JSON file, it could be a YAML file, or a wide range of other programming and markup languages. The benefits of doing this include having all of your infrastructure defined in source control, which gives you confidence in being able to deploy into production because you've been able to easily deploy and test in other environments. It gives you that fully repeatable deployment. Infrastructure as code means you're able to deploy the same piece of infrastructure 100 times and get the same thing every time. There is no manual configuration needed here. There are no clicking around UIs or forgetting to set something up properly. It's just all defined in code for you. On AWS, CloudFormation is their first-class citizen for infrastructure as code when you're provisioning resources on their cloud. CloudFormation can sometimes be a bit verbose and unwieldy to work with, so over time, abstractions have been built over the top of it. Things like the third-party serverless framework, AWS's own SAM tooling, and of course the CDK. But with all of these infrastructure as code tools, the fundamental core concept behind them remains the same. They allow you to store and define your infrastructure as code. So, how does the CDK fit into all of this? The Cloud Developer Kit was first introduced by Amazon in July 2019 as a code-first approach to building out infrastructure. Where CloudFormation is usually written in JSON or YAML, the CDK allows you to define your infrastructure in your favorite programming language, as long as your favorite programming language is Python, TypeScript, C#, Java, or Go. And for the remainder of this talk, we'll be focusing on using TypeScript. So this allows you to write your infrastructure in the same language as your application. So it means you don't have to learn any of the custom features of your infrastructure languages like CloudFormation. So the CDK itself, each CDK application consists of an app, that's the CDK app, which is the entry point of the application. And this CDK app consists of one or more stacks. And these stacks are usually relatable to or very much the same as a CloudFormation stack. And each one of these stacks consists of one or more constructs. And these constructs might be the actual individual resource that you want to deploy. So you'd have a construct that might define an SQS queue. You might have a construct that would define a lambda function. And when using the CDK with CloudFormation, all of these constructs provide a varying level of abstraction over CloudFormation itself, ranging from a very thin layer exposing native CloudFormation itself in the L1 constructs, through to L2 constructs, which include AWS-defined sensible defaults for these cloud resources, like a common way to create a Node.js lambda function or a DynamoDB table, all the way through to the L3 constructs, which comprise of various AWS services all integrated together in some more common patterns that we see. So that's maybe things like an S3 event notification getting published to an SMS topic going on to an SQS queue. You could bundle all of those resources up into a single L3 construct. So we'll be looking at an example of how we create our application. It's got a front end and a back end, and we'll have two stacks for this. Our front end stack will contain our React application served from an S3 bucket, and our back end stack will contain our API gateway, our Lambda functions, and our DynamoDB table. And we'll be doing all of this to create a simple app that allows us to submit tasks, a to-do task API and website. How do we use it all? So, the CDK itself provides some libraries that we'll be using in TypeScript, but it also provides CLI tooling that we use to get started. So we'll be using the CLI command CDK init app, and then we'll be passing it the app name. We've called it CDK demo, and telling it that we want to use the TypeScript language. Then behind the scenes, the CDK is going to bootstrap a few files for us. It's going to have our CDK configuration file, and it's going to have our app, our CDK app file, where we'll start to define the stacks or the CDK stacks that we want to create. So let's have a look at what this command might output for us. So here we go. We've got our CDK application, and inside this application, we're creating a new CDK app. So that's line 6 there. And we're importing the CDK here from Amazon's managed CDK library. And then we're creating two essentially stacks. We've got a CDK demo backend stack and a CDK demo frontend stack. And both of these are stacks that we're going to manage and create ourselves, and they're both going to inherit from the CDK's base stack class. And you'll notice that we're passing the stack in the application into both of these stacks. That's so that when the CDK goes on to generate the CloudFormation for us, it knows the scope of which application these stacks exist. And you'll notice that we're passing this same scope, the application, all the way through into our constructs as well. And that's just to help the CDK application and the CDK tooling know what stack to generate these constructs within. So let's take a look at our backend stack first. Here we've got our CDK demo backend stack, and we can see that it's extending that base stack class from the CDK library. And we're passing into the constructor that's scopes, that's the application, an ID, and some additional props that we might want to pass in. We weren't doing any of that. And then we'll define all of our constructs inside this class. So we'll be creating our lambda function, our DynamoDB table, and our API gateway here. All in all, the backend stacks are around 100 lines long or so. So let's see what it looks like to create a construct. So our first construct is our DynamoDB table. We're creating a new DynamoDB table, passing this in. That's the scope of the stack that we're creating. And we're giving a few properties that DynamoDB require. So we've got a partition key there. We're just setting that as ID and setting its type to string. And then the sort key, we'll be using task here as the sort key and passing that in as a string as well. We're giving it a table name, we've called it Ryan CDK demo, and set a removal policy to destroy. That's just so that when I tear the stack down at the end of the day, the table will be deleted as well. That's really helpful in development environments because it means there's no underlying residual cost you have to pay, but you might not want to do that in production. And that's it. That's all we need to do to define our DynamoDB table. So next, let's have a look at defining a lambda function. We've got our add task function here. So anytime a user wants to add a new task to our database, we want to store it in DynamoDB, and we'll be using a lambda function to do that. So we're giving it a function name, calling it Ryan CDK add task, and we're passing it an entry point. So I'm setting this entry point to be some TypeScript code that we'll look at in a second, but you'll notice that I'm actually setting the entry point here to be TypeScript. I don't have to worry about the bundling or the compiling of my TypeScript functions. The CDK does all of that for me. And then I'm setting up an environment variable. So we want this lambda function to be able to write to our DynamoDB table, but we don't want to be hard coding the table name of this Dynamo table everywhere and pasting it in a bunch of different places. So we're setting it as an environment variable that our lambda function will read, and we're just referencing that task DynamoDB table that we just created, and we're referencing the table name property on that. That means that if we ever have to change the table name for any reason, it will just flow throughout our application, and our application will be reading it from the environment without having any hard-coded values anywhere. And then finally, at the bottom there, I'm granting read and write access on the task table to this lambda function. And this is one of the really nice things about the CDK. It allows you to create least privilege access policies for all of your resources. So we're saying that this lambda function is able to read and write only to this DynamoDB table. We don't have to define those IAM roles or policies by hand. The CDK will do that for us. So what does that lambda function look like? We've got our lambda function here. This is just a normal lambda function written in TypeScript, and you'll notice that near the top, I'm reading that table name from the environment variable, and we'll use that in the DynamoDB client later on. But other than that, this is just a normal lambda function defined and written in TypeScript. There's nothing magic going on here. The CDK just knows how to compile this TypeScript down into a JavaScript bundle, and it knows how to deploy and minify that for me. So I'm not doing anything. After that, we're going to create another second lambda function. So this lambda function is going to be the function that gets all of our tasks or all of our to-dos out of our database. So it's just going to read them all and return them back through our API. So this is really similar. Again, the entry point I'm setting as a TypeScript file. I'm setting up the environment variable, passing in the table name that we need for the function to read it. But then you'll notice down at the bottom that this time I'm only granting read data to the function. So that means this lambda function isn't able to write anything to this table. And if it tried, it would get an authorization error. And again, that's a really nice example of how the CDK is making it really easy for us to ensure we're only granting the least amount of privilege that we need for our lambda functions to do their role properly. So that's our two lambda functions defined. Let's have a look at how we might define an API gateway. So we're going to make a tasks API here, and it's just a normal API gateway REST API. I'm giving it a name, a small description there, and just setting some default CORS options. In production, you may want to make it a bit more restrictive, but for this example here, I would be allowing any website to send data to my API. And that's the base of our API defined. Next, we need to define some routes on the API. So we're going to create two routes. One, the post route for adding new tasks, and one, a get route for getting a list of all of the tasks back. And you'll notice that this is really, really simple. So on my tasks API, I'm adding a method, the post method, and then I'm creating a new lambda integration. That's the add task function. And this is an example of the lambda integration of one of these constructs that Amazon give us some really nice, easy to use defaults. So we don't have to worry about any of the API gateway integration setup or anything, or the IAM policies that need to be created here. We're just saying, quite simple, this is a lambda integration, passing in that function that we want to be the other side of that post endpoint, and the CDK is going to wire all of that up for us. Likewise again, for that get method, we're just creating a lambda integration here and passing in that list tasks function. An API gateway is going to wire all of that up for us under the hood and makes it really, really easy for us to create that API. And that's it for the back end. So there, in I think maybe about 100 lines of code, we've defined our DynamoDB table. We've defined two Lambda functions, ensuring that both of those have got the least access, the least privilege that they need to do their role. And we've created an API gateway. We've added two methods or two routes to that API gateway, both with Lambda integrations, one for each one of those functions that we've defined. And the code for that second function, we didn't look at there, but it is on my GitHub if you want to have a look at it after the talk. So let's take a look at what we might need to do for defining our front-end stack now. So very similar again, this is going to be our front-end stack, and it is extending the CDK base stack class again, and we're going to be defining a couple of constructs inside this stack. So first up, we're going to be defining a web bucket, and this is going to be our website bucket. So this is where the website will be getting served out from. So we need to let S3 know, Amazon S3 know what the index document is. We're saying index HTML. And we're setting read access to be true. That's because I want to serve the public, I want to serve this straight out of the S3 bucket. Usually you might go via CDN or something. And I'm setting the bucket name to Ryan CDK demo. And that's all you really need to set up an S3 bucket that would allow you to do web hosting. But you'll notice that we're not actually doing any of the bundling or uploading any of our application or React application files to this bucket. So we'll do that in a separate construct. Here, we're creating our deployment bucket. And this is actually just creating another S3 bucket behind the scenes, but it's doing a few other things for us as well. So you'll notice that we're setting up some sources, and I'm setting the source asset to just be the output of our website build function. So when we're compiling our React application, we might have our the output bundle getting output to this website directory, and we're passing that in as the source for our website. Next, we're setting a destination. So we're just setting the destination bucket as our web bucket. So what's going to happen is under the hood, that when we deploy this application, the CDK is going to create two S3 buckets essentially for us, our website bucket and our deployment bucket, and it's also going to provision a Lambda function behind the scenes for us. We don't need to know about it so much, it's just you need to know that it exists and it's there. And when we deploy this, the CDK will upload our assets to the deployment bucket, and the Lambda function will then trigger, and it will copy our website files from our deployment bucket and put them into our website bucket. And that's just so that you don't always have to have your website bucket being the same place that you're deploying to, and you get that nice separation between it. But under the hood, the CDK takes care of a lot of that for us. And that's it. That's all we need to do for our front-end stack. So we've now got our CDK application with our back-end stack and our front-end stack. Everything's defined inside it there. Next, we'll have a look at how we'd actually go about deploying this. So when we're deploying our application or our stacks, there's a few CDK CLI commands that come in really helpful. There's the CDK diff, CDK synth, deploy, and destroy. And we'll take a look at what each one of these actually does. So first up is CDK diff, or difference. This is a really important and useful command to help you understand what's different about the infrastructure that you've defined in TypeScript locally and what is already deployed out into your AWS account. So up at the top, you can see that I've got a plus sign under some resources, and I've got an AWS DynamoDB table. That's letting me know that what I've currently got defined in TypeScript, when I deploy that, it will create a new DynamoDB table. And we can see there that I'm creating some IAM roles and policies. That's what the grant read or grant write access would do. And I've got my AWS lambda function, the add task function, would also be getting created there. I ran this command when I had nothing deployed. So inside this CDK diff, I would see a list of every single resource. It's a way to get created when I would first deploy this. So it's a really useful way to see what's actually going on under the hood. Next, we've got CDK synth, or synthesize. So I mentioned right back at the start that the CDK eventually compiles down to CloudFormation, and it's that CloudFormation that we deploy. We can use the CDK synth command to actually generate that CloudFormation document for us. So you can see an example here. This is a small snippet of that synthesized CloudFormation document that we've got that would define our DynamoDB table. And here we can see the TypeScript definition for that DynamoDB table. So on the left, we've got JSON CloudFormation, and on the right, we've got TypeScript CDK. They both create the same DynamoDB table, but the TypeScript one I think is a little bit easier to read. We get some of that type safety that TypeScript gives us as well with some required properties, rather than all of the stringly typed properties that you get in the CloudFormation. And it's, I think, really interesting to note here that, again, I mentioned CloudFormation can sometimes be a bit unwieldy to use and write yourself. These two stacks, when it's all synthesized down to CloudFormation, actually ends up being somewhere around 1,600 lines of CloudFormation. And that's certainly not something that I would want to have to write by hand myself. Whereas our TypeScript, our two CDK stacks, they're around 150 lines of code. So that's about a 10 times difference with the amount of code that you save, with the CDK doing all of the heavy lifting under the hood for some of those things that you don't always have to want to think about or care about. So it's really, really helpful and speeds up a lot of this development process and time. Then we want to actually deploy our application. So we've now got our generated CloudFormation. Let's deploy that CloudFormation to our account. So for that, we can use the CDK deploy command, exactly what it says on the tin. It will deploy our CDK application. And because we have two stacks defined, the CDK will deploy two CloudFormation stacks for us. And the CDK tooling, the CLI tooling here in the CDK makes it really easy for us to see some of the more detailed or important things that are going to change when we do run a deploy. So by default, when you do run the deploy, the CDK CLI is going to give you this nice table and let you know that there's a couple of security related changes that are waiting to be made here. So these are the IAM statement changes that we made. So some of those policies and roles that have been created automatically for us, it's just letting us double check, do you want to see what you're away to change with some of those security concerns before we deploy? So this is something that's always really, really useful to just double check before you do deploy. But if you are running it through a CI or CD tool, you can override that and just have it deploy every time without that manual check. But I think it is something that's really, really useful to just double check and see yourself. And then finally, there's the CDK destroy command. That again is really, really simple and does what it says on the tin. When you run this, it will tear down your CDK stacks. All the stacks inside your CDK app, it will delete all of those resources and tear them down. Really, really useful for maybe running at the end of the day on a dev environment so you don't incur any costs overnight. And because it's all infrastructure as code, when you start again the next day, you can just run CDK deploy and everything will just deploy again and be in exactly the same state. So we've now deployed our application into production. And the CDK sounds great, but why might you not want to use it? So let's have a look at some of those trade-offs. Because it is software engineering, everything comes with a trade-off, and there's almost never the best tool to use. There's just the one that best suits your needs. So these are a couple of things that I think it's worth considering when we're considering to use the CDK. So the first one is imperative versus declarative code. So when we're defining our infrastructure in something like a JSON document or a YAML file, we'd be using declarative code and saying that this is what we want it to look like. Whereas when we're writing TypeScript, Java or C#, it's an imperative programming language. We've got some of those traditional programming concepts, variables, loops, conditions, and statements, and it would allow you to make changes to your code that might result in different infrastructure being deployed. That's something that I said at the start, that it's important that when you deploy your infrastructure every time, you get the same result and the same infrastructure deployed every time. But when you start introducing logic through imperative programming languages, that sometimes might not be the case. So it's important to make sure that when you are writing your code, you do write it in a way that would be deterministic, so you do know you get the same result every time. The second one, it's a bit of a double-edged sword really. The CDK is constantly evolving and updating. There are minor releases every 4 or 5 days, and whilst these are non-breaking changes, I think it sometimes is important to be aware that some of these changes are happening, and you can refer back to the documentation to see what has changed when you do come to update it. There might be new constructs released that allow you to simplify the way that you're doing things, or there might just be new features that are supported as a result of the update. And then finally, some of the things that the CDK does do behind the scenes. So whilst it is really, really great that it is creating all of these IAM roles and policies for you, and you don't have to do very much to do it, there are some constructs that sometimes do a bit more under the hood. So there's that deployment bucket that's creating a lambda function that you might not be aware it's creating. So it does do some of that just behind the scenes stuff automatically for you, which is why it's sometimes important to use things like CDK diff just to double check what you've got deployed versus what you've got defined locally, that there's nothing that you're going to be deploying unexpectedly there. Sometimes some of these resources could incur a charge when they're used. So in summary, we've looked at a little bit about what infrastructure as code is and how the CDK fits into that. Then we've looked at how you would define a backend CDK stack inside our application with a DynamoDB table, some Lambda functions and an API gateway. Then we've looked at how we could use the CDK to deploy a React application to S3. And then we had a look at some of the CDK CLI commands that you've got and how you can use those to really understand what the CDK is doing, but also deploy that application out to the AWS cloud. And then finally, we discussed briefly some of the trade-offs that you might want to consider when you're using the CDK. So thank you very much. I hope you enjoyed this, and I hope you've enjoyed the rest of the Serverless Days conference. I'm Ryan Cormack. You can reach out to me on GitHub, although I think we might have some time for some Q&A now. But if not, please feel free to reach out to me on Twitter. And all of the code examples that I shared there are all on my GitHub account. Thank you very much.
Awesome. Thank you for that amazing talk, Ryan, about creating a full stack TypeScript application with the Cloud Developer Kit. I especially really liked how you actually went through the code with us and explained line by line, and how you walked through each section of the application from the back end to the front end to the database. And it was really cool to me how it was actually all in TypeScript, so you don't have to worry about all these different languages. For our next talk, we're going to be with Darren, and we're going to be learning about function orchestration in the world of serverless. So Darren, he received the Microsoft prestigious Regional Director Award for 13 consecutive years, with multiple Global Gold Impact Awards. He holds Microsoft's Most Valuable Professional distinction for 14 years, with a focus on AI and Azure. Additionally, Darren has led multiple SaaS startups for 8 years, launching cloud and appliance products. With that said, let's get started with this workshop.
Hello everyone, and welcome to Serverless Days Student Edition, to this session where we're going to talk about function orchestration in the world of serverless. So what does that mean? Let's start. So, okay. So there are obviously two ways to do this, but again, what is the high level, intro to this, right? So this session assumes that you at least so far, you have built a function or two. If you didn't, you might have a little bit of a difficulty understanding what's going on here, but that's still okay, to be honest. So a function, in the context of this session, think about a function as an API. Let's take it as simple as that. So, So once you start building, functions, and you keep building and building, what you end up having is a bunch of functions, right? It's kind of obvious, but when you have hundreds of functions, then what you see is that not all of your functions are actually exposing functionality to the outside world. but some of your functions are actually being used by your other functions. And some of your functions are actually handling some workflows. They're doing something, then they have to do something else. You figure out that your functions are actually turning into a big monolith, right? Doing a couple of different things that could have been separated into smaller pieces. And that separation could even be helpful to scale the functions themselves, right? So let me give you an example. When you're starting, when you're going to process an order, right? A shopping basket, you have a function that's going to process the shopping basket. You take the shopping basket, and then most probably you're going to need to do something per item in the shopping basket, right? You're going to change the inventory and so on and so forth, right? A lot of operations per item has to be calculated. Maybe you're going to go and check inventory in a third-party system, reach out to another system, right? So there's a lot of work that needs to be handled per item, but on the high level, what your function is supposed to do is to process the shopping basket because it's processing an order, right? So in this case, you can definitely have a single function that does the whole thing from beginning to the end, but most probably you're going to have some difficulties, or it's going to get a little bit complex to scale out when you're going to process multiple items in the shopping basket, because then you have questions like, hey, am I going to do this sequentially, or am I going to do this in parallel, and how I'm going to do that? And don't get me wrong, there aren't solutions to these questions. There are solutions to these questions, and that's what the session is about. But long story short, this is one of the problems that we're going to talk about. Another problem is maybe, you have a very long process, and you don't want to have that, in a single function, but mostly have it, from one function to another, because one function is calling another, the other one is calling another, and then you have sequentially a chain of functions, essentially. That's another scenario that we're going to talk about. Another scenario is when a function has to wait for a third-party system, right? It does something and then has to wait for something to happen outside of your world of the function app, right? So those three scenarios, we will talk about these in detail. But my point is, once you have, once you're building more than one function, right, then you are getting into this world where you are a little bit worried about, hey, how I'm going to orchestrate those functions in terms of how do I manage how they talk to each other? How do they get things done in a cohesive manner? How do they work together, and how can I see that from a high level? How do I do the orchestration? Because having multiple functions, accomplishing a single job together, and especially when you have multiple, things to accomplish as part of a function solution or a function app, then that look gets more complex. Every time you add more functionality, you end up having hundreds of functions. Some of them talk to each other, some of them don't. You kind of lose track of which one is talking to which one, and so on and so forth. And when you introduce changes, you risk introducing breaking changes across your functions as well. And I am assuming you don't have unit testing or integration testing. Those are definitely a separate discussion that we should take a look at. So long story short, what we have here is two solutions. The first one is the Azure Logic Apps. Azure Logic Apps helps you when you want to orchestrate your functions in a visual plane. So you want to see things, right? You want to have a diagram and be able to play with it. Right. So this is especially very valuable if the workflow is going to be manipulated or edited or changed by someone who is maybe not a developer, right? And that happens. You have business people in the process, and they would like to change the workflow, change some of the statements or conditions, how the business runs, that is reflected into your code. Right. So the Logic app makes it really easy, and we will look into that. We're going to have a demo. The other benefit of Logic app is the concept of connectors. So Logic app has these connectors that can make it really easy to integrate with third-party systems, such as if you're going to use some Twitter APIs, there's a Twitter connector. If you're going to use some Office 365 APIs, if you want to trigger a function when there's a new email in an inbox, so you can definitely build this thing from scratch. But then if you're using Logic apps has a connector for Office 365, and there's a tons of connectors in logic apps. So those connectors, it makes it really easy to get things out the door, to ship, production stuff. I'm not gonna say it's as cheap as building it yourself in the short term, maybe, but at the end of the day, whatever you build, a line of code that you write, is a line of code that you have to worry about and you have to maintain on the long run as well. So sometimes it's better to offload it to someone else. And in this case, these connectors might be that leverage to push functionality out there without really worrying about, hey, are my integrations with these third parties still healthy and running, because someone else is providing those. So that's where Logic App shines. The other solution that we have is Azure Durable Functions. So Durable Functions is a way to build stateful functions. It helps you persist the state of a function and then have multiple functions work together, because it is handling the state transition from one function to another for you. Okay, so it's a way to codify essentially the workflow into your C# code, right, or JavaScript code. So these are the two products. Durable Functions, I'm not sure if we should call that a product. It's essentially a library that you add into your function app, and it's not a service. It's just a library that you add. It depends on a storage subsystem, obviously, that we will talk about. But other than that, it's not a hosted service like Logic Apps is. I have to sip through this because I have sore throat, and unfortunately, I waited for it to go away, but I will miss the deadline for this session. Cool. So what about durable functions? Let's talk about it a little bit. We did mention stateful functions, right? It manages the state, it checkpoints for us, and it restarts our functions when needed. And restarting means replaying back our function. I believe the best way to showcase this is actually to go and see it in action. And for that, I'm going to jump straight into, let me do this, our first problem. Yeah, problem one, function chaining. This is what we have already discussed. Like, I have one function that goes and outputs something that another function has to take over and then process and continue, and then another function takes over, and so on and so forth. So again, this is pretty doable, right? You can have queues between every function, and you can have a function listen to a queue, another one can put messages into a queue, and so on and so forth. But you are doing a lot of plumbing, right? First off, you don't want to do that, obviously. And then one of the benefits of this concept is the fact that, when a function does process a particular job, and the end result might be multiple jobs out of that. So think about the shopping cart, which is actually my next example. Let me jump into there to go a little bit faster. Fan in, fan out, right? Function one is outputting a lot of jobs as the result of whatever it does, right? Function one takes the shopping cart, it processes the shopping cart, it does some validations, checks, and so on and so forth. But then there's an additional, a job that has to be processed per item in the shopping cart. So the first message comes in, shopping basket processed, and then in the shopping basket there were 50 products. So I'm putting 50 messages into the next queue. And then someone else has to take, has to take care of those 50 jobs in the queue. So what ideally you want to do is, function two, in this case, you want it to be able to fan out, kind of scale, and be able to process the 50 functions in parallel. One of the big problems with this one is, as you can tell, function three in this case, which is the consolidating function, should only run when all of the function two instances are completed. And this is not an easy implementation, let me tell you that, especially in a disconnected, distributed environment, right? You have 50 different functions, they're running probably on different servers and stuff, and you're gonna run something else when all of them have succeeded, right? They have a result. So this requires a lot of checking and monitoring and so on and so forth. So again, a lot of plumbing in terms of getting this thing running. And all this plumbing can be handled by durable functions pretty easily. So let me show you how that's done. So what I'm going to do is to open up a brand new Visual Studio instance for you. And right now it's opening up on my other monitor. I'm going to bring it up. Come on. Oh, here we go. Okay, let's say continue without code. Here's what I'm going to do. File, new project. And we're going to select Azure function. Come on. Okay, next. The name doesn't matter for now, but I'm going to put this somewhere else. Give me a second. Let me put it into a temporary directory. Function at 1 is good. I'm going to say next. An HTTP trigger, that's okay. We're going to go with .NET 6. That's okay. Authorization level, let's make it anonymous for now to make things easier. So I just wanted to take this from scratch so that you guys can see what's going on. So right now we got a function app with an HTTP API in it. And let me dismiss for now. What I'm going to do is I'm going to right click on that and say add new Azure function. I'm just trying to bring in the new template UI. So I'm like saying, hey, I'm going to add a new function into my project. I say add, and from here I'm going to scroll down and go and pick durable functions orchestration. So when I do this, this is going to spin out some default code that we will look into. So if you look in here, you're going to see that there's a couple of different concepts. The first one is the concept of an activity function. Activity functions are functions that do the actual work. And then we have the orchestrator function. You can see that the orchestrator function in this case is calling the activity function, right, 3 times sequentially. Every time it calls it, it is using this await keyword. And finally, it returns the output. So this is called the orchestrator. Okay, the orchestrator that orchestrates multiple functions, and this is the activity. And then this one is a simple HTTP trigger API that starts an orchestrator instance. So we give it a name, say, hey, this is our orchestrator. We want to start a new one, and then we're returning some response status because this is going to work asynchronously, right? We are getting the instance ID, but start new async means that the orchestrator will start, but we will not wait for it to finish. The output will be stored, and we will go and reach out to that with the instance ID if we want to. So obviously, because of the time constraints in this session, I have to keep things really simple. But what's really happening here is I have an orchestrator that is calling other functions, right, 3 times sequentially. These functions might be running on other servers. I mean, there's no way for us to know for sure because the underlying infrastructure scaling is being handled by the Azure Function Service, right? But we're passing 3 parameters and we're getting the results. The nice thing here is this function, when it comes to this, it's going to call function hello with Tokyo and then go to sleep. So, and that's where the beauty of durable function comes in. Essentially, what's happening behind the scenes is that this is going to be snapshotted, okay? And there's going to be an history table capped. So this orchestrator will be taken into sleep until the activity function is completed. Once it's completed, it's going to restart, replay, but will not run this activity function again, but it will restore its result that it gets from in the initial execution. It will put it into the collection. Then it will run this function with the new parameter and then go to sleep again. So essentially, this orchestrator will run once, twice, 3 times, and then a 4th time when all of the activity functions have been called. And then we are done. The output will be, this is essentially the function chaining, right? You're calling 1, getting the result, calling 2. The only difference is that there's a high-level orchestrator that talks to every function and gets the result. And while it is waiting for the other function, it is not actively waiting, it's passively waiting. It's sleeping. So we are not paying for the amount of compute resources being used. When we jump into, let me go there. When we jump into this particular scenario, right? When we have, let me see. When we have the function chaining scenario, fan out, fan in scenario. So for that, I'm gonna bring another piece of code in here. Let's go with this. Okay, I'm simply going to replace this. The only difference you're going to see here is that I'm not awaiting for every function one by one. I'm calling all of them, and I'm waiting all of them at once. And that's the only difference. So what's happening here is this orchestrator is running. This orchestrator is calling 3 instances of this function with different parameters, and it's waiting for all of them to complete. So the playback count for this function is much lower than the previous one because it's not a sequential call. So it runs once, it runs twice, and we are done. We're going to get all of the results from all of these functions. Okay, I could have 50, 60, 100, whatever. I could have this in a for loop, and the fan out would happen behind the scenes. And as you can tell, there's no plumbing in terms of, hey, let's manage queues, let's manage messages and stuff between those, and there's none of that. We are essentially using, in the case of C#, we are essentially using the task parallel library to manage these as tasks. But what's happening that every task is actually a call, an HTTP call, actually, not literally, but think about it as an HTTP call to another function being hosted somewhere else in the server farm. So that's kind of the durable function scenario shortly. Another use case that is really nice is this human interaction and the eternal process. You can have a function orchestrator sleep forever. There's an API for that, internal functions API, durable functions API for that. You can call that and say, hey, this function, I want it to wait for 20 minutes. It's going to wait passively, so you're not going to pay for it. And 20 minutes later, it's going to wake up again and do something. Another one is the external event. So you can open up a webhook, and your function can wait without paying for the underlying infrastructure or anything because it's going to be in sleep, but it's going to have an event trigger that can be called by a third-party system. So all these scenarios, thanks to a durable function, gets really easy to implement. So, I mean, this slide deck is going to be online, so you can definitely go in and read those in details. There are a couple of things that are kind of important when you are building orchestration with the durable functions. You have to be careful about some of the tips and tricks to ensure that you're using, you're getting the most out of the platform. So that's what this slide is about. We're not going to go into it right now. So the durable task framework has a couple of storage engines that it requires to store the snapshots and the history. So there are a couple of options on there. Azure Storage is the default, but you can go and use something outside Azure as well. So we did discuss a little bit about logic apps, so I want to jump straight into a demo and show you how the same thing could have been done in logic apps, right? So for that, I am gonna bring this one. So this is a logic app. This is a very, very simple one. The purpose is to show you how a logic app could orchestrate a function, right? So I'm gonna say edit. This function app is already built. So it has an HTTP endpoint where we can give a list of image links in an array. So we have a Azure function that we're going to use for this. The Azure function is able to detect food in an image. It only gets one URL of an image and is able to tell us back if there's a food in it or not. So it does the core processing. But what we want to have is the ability to have a list of images and then return back only the images that have food in it. So that's what we want to have. So in this case, we are getting a list of items in an array, and then we are initializing a variable called food images. And you can tell how simple things are in logic apps by how we are defining a variable, right? It's a simple box that we drag and drop. And then we have a for each loop that iterates through the array, and for every item, it calls the food detector Azure function. And then we have a condition. We say, hey, if the result of the Azure function is HTTP 200, it looks like it's how it's built, then there's food in it, and put that into the array that we created. If there isn't food in it, we don't have to do anything. And finally, we are serializing back our array with the food images in it and be done with it. So obviously this can be built in durable functions as well, but as you can tell, the flow, the decisions, sorry about that. So the flow, the decisions are visually, very easy to understand. And these are things that I can change without writing code and deploying and so on and so forth. And this one has only a single Azure function, but you can imagine having multiple Azure functions working together and the relationship between those being built in design mode in a logic app. And on top of that, again, this example isn't using it, but there is the concept of connectors that you can use as part of the logic apps. And that's where the power of logic apps comes in, the connectors and the visual aspect of being able to design the workflow. So with that, that's pretty much all I wanted to cover in this session. 2 different ways to orchestrate functions. Here are a couple of links I wanted to share if you're interested and want to go a little bit deeper. Here is where you can download this slide deck, and my Twitter alias is out there as well. In case you have any questions, please feel free to reach out to me on Twitter, and you can reach out to me on LinkedIn as well. Yeah, hopefully this is helpful. Enjoy the rest of the conference.
Yeah, that was an awesome workshop by Darren on function orchestration and how you can make many Azure functions work together instead of just having everything in just one giant Azure function. I especially really like the analogies that you drew at the beginning about the more complicated aspects of function orchestration and why we might need that, and drawing that shopping analogy into concepts that we might be more familiar with. So for our next talk, it's going to be by Melody Lee about a business card store and information extraction with Azure functions. For a bit of background, Melody was a serverless camp student in this iteration of serverless camp, and the next 6 talks will be all by serverless camp students about their final projects. Melody is currently a high school senior at the North Carolina Schools of Science and Mathematics, and through the BIT Projects mentorship program, her mentor was Christian Lechner, who gave a talk previously, and in there, this was her final project. So with that said, let's get started.
Hello, my name is Melody Lee, and I'm briefly just presenting a little bit on the project developed for the BIT Project mentorship program. Now, business cards are just undoubtedly a rather traditional method many companies use for networking and marketing purposes. In fact, it is estimated that for every set of roughly 2,000 cards or so distributed, marketing sales increased by 2.5%. While this seems less significant than, say, television advertisements, business cards have functioned as a way of connecting companies and industry professionals for centuries, dating back as far as the 17th century. Thus, it's worth noting that the presence of business cards within the corporate world is rather significant. In fact, roughly 27 million business cards are printed on a daily basis, and these are traded regularly at conventions and conferences or just simple day-to-day meetings. Of course, the rise of the digital age has certainly introduced other methods of connection, and the worth of business cards within this context is still rather significant. Oftentimes, these cards contain information such as contact and company information, as well as the names of individuals people have networked and connected with, allowing for future connections and for future conversations to begin. Now, naturally, there are a number of platforms, including LinkedIn and Xing, that are in existence that function as career-based social media and connection platforms. These allow for users to be able to digitally and over the internet contact a number of individuals who may share similar interests or professional areas. However, many of these fail to connect and fail to account for the business cards, the physical component that is traded during a number of these meetups. And as a result, we introduced the project BIN, or our business card store. This card store is aimed at allowing for users to simply send a text message to a predetermined number in order to upload their card to an online database. This will then allow them to access information from that card, as well as look up general information and translate it as needed for their future use. Now, as a brief demo, here we will walk through a little bit of what the product looks like. All right, so this is our business card store dashboard. Initially, the user has already used their phone and text messaging to send an image of the business card that they have collected. Now, in order to load in all of the previous business cards that have already been processed, the user will simply click Find Card and give it a moment in order to bring in all cards that are present. Now, each of the cards are listed in accordance to the name of the individual on the card, as well as the company that they work for. If it is unknown, it will temporarily list undefined. Now, if we are to select an arbitrary business card holder of some sort, in this case, go with their last item, in order to load in the information and display, we select Find Card again, which should show your contact name, company name, and other key information extracted from the card. This could also include, say, fax, or the address, anything. If it was not present on the card, it will not be shown here. Now, of course, the user at times may be asked to find additional information about this person or maybe the company they work for. In order to do so, they will oftentimes conduct a Google search query, and so we have put that into this dashboard here, hopefully to save a little bit of time. Let me shift this down as well. So you can select See Search Results, and using the Google Search API, it will return your top 5 results for your particular individual. The search query generally includes items such as the name of the individual and your company name, which should return several items of key information. In this case, the description, as well as just the site title, and then a link to your site. Users are then able to open up this link. In this case, our individual in question is a particular researcher at KTH in Sweden. And we're able to find additional information on this user. Of course, last but not least, it's worth noticing that business cards are not always just traded within the United States or within a certain language. Oftentimes, it can involve having and requiring a little bit of translation. So we've included a translation function for our card. I'm going to reload the card. It will have to be loaded prior to selecting and translating or getting more information. And so if I'm selecting an arbitrary language of sorts, let's go with Japanese in this case. We can select Translate, which will then give us a translation of our card and preserve any additional information on there. All right, so it's just a quick demo of this particular dashboard. This is assuming that we're looking from the perspective of the user, as you can see with the icon up here. And of course, we have several other key pages on our dashboard. So the entirety of our product can be broken down into 3 main components. 1, the upload function. 2, the storage function. And 3, any information extraction and also displaying of the card that is done. Now, if we're to break down and go through each of these areas individually, we will oftentimes begin with considering how these images and this information is loaded into our dashboard. Well, as previously mentioned, users will take their phone and send a text message to a predetermined number. Now, this number is provided by Twilio, which can connect our phone number with a HTTP trigger. This image is then sent to our card storage function, where it is processed accordingly. Now, this is where we ran into a few issues, namely that the processing function and actually the service that we wanted to use, in particular the Microsoft Azure Form Recognizer, requested that our file type be known, that is, whether or not it's a PNG or a JPEG, etc. This posed a bit of an issue because the way the Twilio API works is that it does not append an actual file extension at the end. So in order to remedy this, we did a little bit of a workaround using Azure Blob Storage as an initial resting place or upload location for the images sent from the phone. From there, while uploading, we manually include and attach the end of our file name, the file extension. This allows for the item type to be known, and from there we can then re-download the image with its new name and file extension at the end of its name and pass it into the Azure Form Recognizer. This Azure Form Recognizer will take the image of the card and fundamentally extract information from it. That is, using a pre-built model that is trained on business cards specifically, it can take out information such as contact name, company name, address, email, website, fax, any key components that are oftentimes used in order to contact individuals or allow for additional search and query into what their service or what their area or professional area is. Now, of course, once this information is extracted, it's returned as a JSON object from the Microsoft Azure Form Recognizer and is then uploaded to Cosmos DB. Cosmos DB, or your database in this case, will store your JSON object and until it has been called from your dashboard using the find card function. So now we consider the two information analysis components of our dashboard. Initially, the user will be able to call information from the card or a particular card they choose using the find card function. This simply takes a JSON object, calls it, and then from there displays it on our corresponding dashboard. In order to conduct a search query, it would take in the objects or the items from our display as a JSON object and pass it through a function that will then send a request to the Google Search API containing information about the card name and the company name. That is the individual who gave the card to a person, as well as the company that they work for. From there, the Google Search API will return a series of top results, and our Azure function will select the top 5 and display it accordingly on our dashboard. As previously mentioned, this includes your title, your description, and a link to the said website, allowing for our user to look a little bit further into who our individual or who our person, or maybe even just who the company is for our particular card. The results, of course, are displayed as follows. On this mode dashboard, we have included also a clear functionality. So once the clear button over here is selected, it will essentially empty this particular box here to allow for maybe another card to be selected and more search results to be returned. Now, the second component of our dashboard is a translator component, which allows for users who may not entirely understand or would prefer for the card to be in another language to use and translate the information on the card. So what it does is it takes in our target language, which is selected by the user from any of the languages supported by our Azure Cognitive Services translator, as well as just the specified card information, including, again, key contact information, name, and company. This is then passed through our Translate Business Card function, which utilizes our Cognitive Services translator and sends in a JSON object containing the card information and the language to translate to. And our Cognitive Services translator will return this translated text, again, as a JSON object. Our function will then send this JSON object to our front end or to our initial dashboard, and dashboard will process this information and display it accordingly for the user. This then is displayed as follows. Here we have selected Spanish for translating our card, and as you can note, the website and address and email address have all been preserved. All right, so with regards to where this project can go as next steps or as a series of next steps, there's quite a few, namely one, just creating a little bit more user-friendly interface and a dashboard that is a little bit more accessible to individuals and a little bit more intuitive. As can be noted currently, the dashboard consists of all 3 functionalities just directly one after another. Now that does, of course, while it is wonderful to have it all on the same page, it does create a little bit of functionality issues, especially when the list of items becomes rather unwieldy or long, especially, for example, once the search query is done, you will have to scroll to the bottom in order to utilize, say, the translation function. That is, it can be rearranged in a little bit, allowing for maybe additional tabs within our dashboard or website, as well as, actually, as our second item, user storage accounts. Implementing a way for users, depending on the phone number that they use, to send in an image and have that stored directly to under their specific name or user account. This will allow users who do send in cards from different phone numbers or different users who do want to keep their information separate from being able to see other users' information. So utilizing that as well as creating a bit of a login, etc. For the dashboard will always be a next step. Lastly, it is always also useful to utilize and implement a card organizational system. As seen previously, currently the cards are simply listed by name and the company they work for without any added tags or display information included. Of course, they could present a few issues, especially when some time has passed and the name or the company is no longer a recognizable item. So being able to efficiently go through each one of these and load and look at what they are about, at least at a little bit of either a faster pace or alternatively with just a simple query or a search for related items or related topics would always be useful. Nevertheless, I did want to go ahead and thank multiple people, including my mentor, Christian Lechner, as well as the Bit Project team for making this entire program and this project possible. So thank you very much and have a wonderful day.
Awesome. Thank you, Melody, for your final project and all your hard work in Serverless Camp this summer. I really love that you added a lot of features to your project, not just like saving business card, but also like the Google search and translation features. I thought that was really neat that you included them. Our next project will be from Jalen, who is currently a sophomore at Purdue University, majoring in computer science and applied statistics. His project title is called Helping Purdue Students Poop. And I honestly really like it. And I'm not going to spoil it for you. But with that said, Jalen, let's take it away.
First off, big thanks to the Bit Project team and everything that they've done. They've done so much. And this program has been something really valuable. And I've learned so much this past summer. And thank you to everyone who's watching as well. It means a lot. So Purdue Poopers is the culmination of what I've learned with Bit Project this past summer. A little bit about me. My name is Jalen Chang. I'm a rising sophomore at Purdue, majoring in computer science and applied statistics. And focusing on the computer science, I'll be focusing on the software engineering track and the machine intelligence track. I'm from Carmel, Indiana, so close to Purdue. And some of the things that I like outside of school is playing my viola, listening to classical music, cooking new foods, which I've been doing a lot more this past summer, playing CSGO with friends, and listening to podcasts, specifically Lex Friedman and Andrew Schultz. So my inspiration for Purdue Poopers originated in my first ever college visit. I woke up bright and early in the morning and I drove 3 hours to the university, but once I got there I had to poop so bad since I haven't pooped that morning. And so once I got to the visitor center, they said, sorry, we haven't opened yet, so the restrooms aren't allowed. And I was crushed because I had to go so badly. I had goosebumps on my arms, and so I rushed onto campus to the nearest building just to find a restroom. And fortunately enough, the doors were unlocked, but I looked through the whole building. On the first floor, no restroom. Second floor, I found the women's restroom, but unfortunately, I didn't feel comfortable using that. And then so I went all the way to the top floor, the third restroom. I finally found the men's restroom, and it was my oasis. And it was just a real struggle since all universities, they have campus maps, but the campus maps don't ever show the bathrooms. And if the building does even have a bathroom, it could be on the third floor, it could be on the second floor, or they could even have one on all 3 floors. I didn't know. And I've seen this problem rise time and time again with new professors, prospective students, and even new students, and even current students. One time I had to help direct my professor to the nearest restroom since he was new onto campus and he hadn't even been in that building before. So this problem really relates to everyone on campus. New students who are just getting onto campus, figuring out their schedule. Sometimes they need to find a place to poop, or even new students or current students who are going through their schedules, figuring out when to poop with their schedule. You never know, and everyone has nature's calling whenever they have it. So here are the technologies with Purdue Poopers that I learned during the Bit Project Camp. So on the front end, I use HTML, CSS, and I also use Bootstrap for the CSS part. On the back end, I had Azure Functions, specifically a HTTP trigger, Cosmos DB, SQL, and JavaScript. The APIs I used was just Azure Maps API, and I also use Node.js to fetch the Azure Functions and to communicate between the client and server. So this map here demonstrates a little bit of the roadmap of Purdue Poopers. So the user submits their user location, and then that goes to the client side of the site, and then that information of the user's location is then sent to the Azure function, which then does the calculations, and then it grabs the closest bathroom location and then sends it back to the user through the site. So starting with Cosmos DB and the SQL JavaScript SDK, this is how I stored all my bathrooms. So in this picture, you can see that I had an ID, name, location, and this location was formatted in GeoJSON format. And so I had a coordinate of where it was, and the name and the ID. And yeah, so this SQL query here was actually in my Azure function. And this query, as you can see, finds it takes in the longitude and latitude of the all the points within 100 meters, but then it also calculates your distance from each of those points. And later in the Azure function, I'll calculate the distances and sort them to the lowest one to know which one is the closest bathroom. Going back to the front end, I use HTML, CSS, and Bootstrap. So this is basically a picture of what the site looks like. This submit location button asks users for their location permissions, and if it is denied, it gives the necessary warnings or error handling, as you can see here in this function. And if you do allow it, of course, it'll show you the nearest restroom. So other than that, this map is also navigatable, it is draggable, and zoomed only onto the Westloft campus, so then you can't accidentally drag yourself to IU Bloomington, for example, to the middle of nowhere. So going over some challenges that I had many challenges. One was learning many technical things very fast, such as HTML, Bootstrap, and SQL, as I mentioned before with that query. That query was actually very tough since there was things that weren't supported by Cosmos DB, such as order by, so I had to figure how to order things without using an order by. The SQL script, and not only was creating the SQL script a challenge, but really implementing that into a Node.js console app with the JavaScript SDK. So meaning basically implementing it into my Azure function and using the Cosmos DB library to communicate to Cosmos DB on the server side. And then my last challenge was the blending of the client side and the server side. In the beginning, when I was developing my web app, I had everything tested and created basically on the client side, but I just wasn't sure on how to implement it into a Azure function. And what I did was I ended up taking my Node.js console app. So basically the main function that does the calculations and putting it to my Azure function, because I was testing it on the client side and I just didn't realize I could just even put that in. So the blending of the client side and the server side and sending the information between them was a big challenge for me. And so here is an actual demo of it. So here's the site. As you can see, this map is fully draggable. Here's a view of Purdue West Love campus. Each of these points are bathrooms, and the ID is the number that's on them. So if I submit my location and I allow it, it shows that my nearest restroom is number 2, granite floor and 1, right here. Happy pooping. So yeah, this is a demo of my site and basically shows you the nearest restrooms. Some future plans that I want to add with Purdue Poopers is firstly a routing with Azure Maps API. As of now, it's just the map that you saw on the client side. It just shows where they are and it allows users to find specifically where specific on campus are their closest bathroom. So adding a routing function with Azure Maps API is something that I want to do, considering it's already implemented. I just have to add more functionalities from that API. Another thing that I want to add is a social media aspect to the site. So that's probably the second half of the site that I would want to add, which would contain a rating system where users can create accounts and rate the bathrooms that are on campus, and maybe even upload pictures to show how clean or even how dirty they are. And this would have to have a concurrency aspect to it where multiple users could be on at the same time and it'll be updated accordingly. So that concurrency aspect is something that I foresee as something very difficult and a big challenge in the future. So that is Purdue Poopers. I hope you enjoyed the presentation.
Yeah, that is super awesome, Jalen, especially your Purdue Poopers app and how you actually used it to solve a personal problem that you were facing. I really like the personal anecdote that you had at first about how you couldn't find a restroom on your first college visit. And that just completely made me crack up. For our next talk, it will be by Jack Shun, and he's going to be presenting a media collection web app. Jack is also a Serverless Camp student and also a computer science student at the University of Utah. His passions are solving problems and learning how to solve harder problems. He dabbles in all things computer related and enjoys long walks, fantasy novels, and tinkering with new tech. With that said, here's Jack's final project.
Hey, my name is Jack Shun. Welcome to the presentation of the final project that I made for the 2022 Serverless Camp. Let's start out with some introductions, shall we? Who is Jack Shun? Well, that's me. I'm a computer science student at the University of Utah. I'll be starting my sophomore year very soon. I'm interested in many topics, but with the experience that I've had so far, I think that data science is the field that I'd like to pursue. I'd really like to do academic research with my time at the university. However, I like to experiment with lots of stuff, and I've had a lot of fun with web development and app development. I'm super excited to have been able to participate in this camp and work on this final project. I really enjoy learning new things, and I've liked to dabble in lots of stuff and tinker with new technology. I'm excited to show you the project that I made, so let's jump into why I made this project. Here's the problem. I wanted to tackle something that I've encountered in my daily life, something that I thought would be useful to me and maybe to other people too. You see, I like to keep lists of the movies I've seen and the books I've read and things that my friends recommend to me and just things that I've enjoyed in the past. And if you look on the screen right here, I used to just keep everything in a big note, I'd open up my note app and I would make one big sprawling list of everything. And it's pretty easy to update. You just pick a new line and write whatever you want. But it doesn't look very nice, and it's not very easy to organize or to fit extra information in. Usually you only get the title of something, and that's about it. So I wanted to work up a solution for this problem. There's kind of some solutions out there already. I mean, you could go to IMDb and you could make a watch list of all the movies you want. But then if you wanted to keep track of your books, you'd have to go to Goodreads, for example, and then make a list of the books that you've read. And then, you keep your songs on your Spotify or your Apple Music or whatever, I didn't like that it spreads out my list, right? Now when I want to keep track of my stuff, I have to go to all these different places on the internet. That's really why I was keeping them in my Notes app, because it was all just in the same place. So the solution that I want is something like what these websites offer, where you can keep a rich list with lots of information, but I want it all centralized in one place where I can keep my movies and my books and whatever I want. So here's my solution. I came up with collection. This is a play on my name. My last name is Shun, so you're making a collection of things. The vision for collection is a website to save your lists of movies, books, songs, hopefully much more in the future, whatever you want, and then to utilize the power of the internet to pull information from some of the generous providers of information, like the ones I've listed here, IMDb, Spotify, Google Books, to create more than just like the title. You can save pictures and supporting information about these things that you like. So that was the vision for my project, and then thanks to the things that I learned in Serverless Camp, I was able to take all the tools that I learned and accomplish something pretty cool. Let's jump into a demo. I thought it would actually be cool if I bought a custom domain for this website, so I did, and I set it up. So fingers crossed, if anyone wants to follow along, they can go to this URL, collection.com, and follow along if you want. So here we are at the URL. If it's just a gray screen for you, just click the reload button and it will just come. It just has to grab all the different parts. So then you're on the login screen. You have two options. You can log in with Google, or you can just use a username. I'm going to use Google. It's a little more secure. And then it will pull my information from the database down, and so then I get the lists that I've been working on in the past. So let's open up the movies list. Right now it's empty. I can come in here and just add text. So I can do The Batman is a movie I've seen recently. It's just Batman fights the Riddler. So I'll save that, and then it has a date here. I can say when I watched it. So I watched it last month sometime, and that's cool, but it's kind of similar to like what my old method was, where I was just saving them in notes, just writing down the title. The cool new thing that you can do is you can search for the movie. So if I want to search for the same movie, Batman, just search for it. It'll go to IMDb and find Batman movies. This one is the one that I'm thinking about. I can just add it, and then everything is auto-filled. So the title, the year, the plot, the poster art. I can leave a comment. I can say, I watched this in theaters. If I spelled it right, that would be cool. Change the date again, maybe I want to delete that old one now that I have a new one. Cool. You can do the same thing with books. So I can come in here. There's a really good book author, Brandon Sanderson. Maybe I'll search for him. Oh, you might notice I searched for movies. I got to change that to books. Search for books. There we go. Brandon Sanderson. This is a good book. Add that one. I recommend. We got the title. We got the author. We got the year. We got the plot. Ooh, the page count. That's a big one. You can do the same thing with songs. So maybe we'll make a songs list. We got to change the search to songs. There's a really good band called Caravan Palace. They have a song called Moonshine. I really like that one. So we can search specifically for that, and voila, right there. We got, we can tell it's the right band, the right album. We can add that. We got all the information, band, year, band, title. We got the art. We could add a comment if we wanted. But you don't have to, you can mix and match stuff too. So in our favorites, we got a movie, we got a book, and we have a song. All this information is pretty much editable. You can just, come in here and change it. You can add comments. A cool feature is you can click these link buttons. So the movie has one, the book has one, the song has one, and then it's going to pull up your IMDb, Google Books, Spotify. You can get more information. You come back. Maybe you've been making changes and you want to go to a different website. Say you want to open up Facebook. It's going to warn you that you haven't saved your changes yet. Oops, we want to do that. Press cancel. Click the save button. Now that's going to save to the database. So next time I log in, log out, log in. All my changes are still going to be here, all the books that I added. And so, you can really save this information on this website. And I'm hoping this will be a better experience than it was just in the notes. I'm hoping that I can add some more features, maybe like video games, maybe like TV shows. And so I think, as I use this, it'll just get better and better. And that's the demo. Now that you've seen my app in action, you might be wondering what makes it tick. Now, I built this app at Serverless Camp because all the pieces that make up this app are running on Microsoft's Azure servers. For very cheap, my website and all of its parts can exist on the internet without requiring me to buy my own server and maintain it and keep it in a secure location. I can just use Microsoft server. They take care of it for me, and I just pay a little bit of money for the small portion of their servers that I use to host my app. Let's look at this flowchart and break it down a little bit so we understand what's happening here. Azure has a product called Static Web Apps on the left. Static Web Apps is a product that packages the code that makes up your website and will send it to a browser when they go to the URL for your website. The code is represented here in the website box. In that box, I have the technology that makes up my website. The main technology is the JavaScript framework called React. This is what I use to make the website interactive and to design the layout of the website. I also used Tailwind CSS to style the website and a small amount of plain HTML and plain JavaScript to handle some of the look and the feel of the website. All this code is packaged and then sent to a browser, and that is what renders on your screen when you go to my website. This isn't the whole website though. Static Web Apps also makes it easy to have a simple backend for your website. The backend is just some extra logic that runs only on Microsoft's computer to provide data for your website and to keep some information secure. This is the box on the right side of the Static Web Apps. I have 2 lightning bolts in this box. Each of these lightning bolts represents a function that handles some of my backend information. The function on the top, labeled Database Access, handles the information that comes out of the Cosmos database, which holds the user information, so what lists they're keeping. It takes that and then sends it to the website without sharing any other user's information. It will also take information from the website and save it back into the database when needed. The function on the bottom, labeled external search, takes in a request from the website. It goes to IMDb and Spotify and Google Books. It asks them to do a search. It takes their search, compiles the information, and then sends it back to the website. I wanted to take a couple minutes to go over the code that makes up my website. Over here on the left is the file structure that holds all the code for the entire website. Most of this is actually in 2 of these folders. This API folder has the code for the back end of the website. This is the code that runs on Microsoft's machines and handles the interaction between the database and the website. So fetching users' data and then saving it back into the database. It also handles the interaction between like Spotify and IMDb and Google Books. When you search something, how it fetches that data and then gives it back to the website. Over here in the source folder is the front end of the website. And because this website is built in React, almost all of the front end is written in JavaScript code. This is because React allows you to write JavaScript code that represents how things should look on the screen. It does this by mixing HTML and JavaScript so that you can describe how something looks and how it should interact with the user when somebody clicks it, or when new data is received, or when something else changes. It also allows you to encapsulate your code. So if we look at, say, this item.js file, this code represents what each item should look like on the screen. So in the demo, when I looked at a movie item or a book item or a song item, it was using this same file to describe how that should look on your screen. This is really good because it allows you to write code once and then reuse it many times. So there's only one item file, but it's able to use this file anytime there's a new item so that we don't have to rewrite the same code and there's less chances of us making a mistake. I'm glad I used React, and it was a good experience to learn React. To wrap up, I wanted to share some of the resources that really helped me to make this project. If you remember when I mentioned Tailwind CSS, I used it to do the styling for my website. And as a beginner to web development, I found that the documentation on the Tailwind website was super helpful. They had visuals and descriptions, and it helped me to be faster with my styling, and also I ended up with a lot more understanding of CSS when I was done. I also wanted to mention the online course that I used to get started with React. The course was free, and the instructor did a great job helping me understand the mechanics that made up React. It was this React course on scrimba.com. I used the Postman app, and that was really important for testing my HTTP requests that I needed for my backend functions, and also for connecting with IMDb and Spotify and Google Books. It was also important that I had Google, because I probably Googled 1,000 things to help fill in the gaps in my knowledge while I was working on this project. Being able to find help online was super important for this. I used Figma.com to do some initial brainstorming and design for my document, and that was really helpful. And I used Lucidchart to do the flowchart that you saw a couple of slides ago. All these resources are free, and they're super awesome to use. And I just wanted to close up with a thanks to BitProject for putting together the serverless camp. The camp and the learning materials were super fundamental to the knowledge and the motivation that I needed to complete this project. I'm also grateful that they matched me with a wonderful mentor. Gareth helped me to design my project, and more importantly, he helped me understand about work and resumes and how to use strategies that people are using in the industry. And it's those teachings that I can apply right away and that I don't think I would have gotten on my own. Thank you for listening to my presentation. Goodbye.
Everyone, I'm Beatrix, a community manager at BitProject. So you want to get free shirt? Don't forget to tag us on Twitter about the conference and tag us at bitprj. So, good luck!
And welcome.
Hi everyone, my name is Emily and I'm the co-director of engineering at BitProject.
Hey everyone, my name is Ganning and I'm the co-director of engineering at BitProject.
My name is Beatrix, a community manager at BitProject.
Hi, I'm John Kilmister and I was one of the mentors in this year's BitProject.
My name is Christian Lechner. I am a development architect at SAP, working in the area of the business technology platform, and I'm also a Microsoft MVP.
I think the Serverless camp this year went amazing, and students had so much fun working on the weekly assignments and the final project.
And I got to meet a lot of different students through the global student community.
And I really like to see a lot of students, be it on the individual track or on the global student community track, coming up, making their hands dirty and being highly passionate about learning new things and getting in touch with serverless technologies.
This year it's been really good to see students progress through the course. They've asked so many insightful questions, both about the industry and also about the technologies in use in their projects.
Some of the projects that we create in Serverless Camp are a little bit difficult to understand at first, and that's what's expected of students when they first join the program.
From my perspective, the most important thing is being curious and being passionate, being interested in learning new things, in getting in touch with new technologies, in getting in touch with the serverless technology.
We received lots of great feedback on our curriculum, which is always great.
I've seen the students ask many different questions and really show a drive to learn new things.
The curriculum and the way how it is presented, how it is done on GitHub makes it possible to do it on your own.
If you want to be part of Serverless Camp, you can expect things like learning new skills, things like serverless, APIs, web development, and others.
Stay updated with us for the next camp by following us on Twitter at bitprj and always keep checking on our website.
And thanks a lot for all the supporters, be it on the mentor side, be it from BitProject, and all the sponsors that are supporting with the Serverless Days.
Thank you for joining us this year, and a big thanks to the organizer of this year's project.
Thank you so much for supporting us and enjoy the conference.
All right. Okay. Thanks, Jack, for your amazing work this summer. It's really great to see how Jack implement React App and Serverless API to connect the online media collections with the list of our favorite book, movies. So before moving on, I would like to give quick intro about myself. So I'm Beatrix, a community manager at BitProject, and I will take over for the next 4 sessions. All right, next the talk will be Tired of Making Travel Plan? Try the newest trip generator by Noah Chang. So Noah is currently a CS undergrad at University of Southern California. Passionate about human-centered technology, Noah will present the website that would randomly generate a one-day trip plan for you based on your inputs of location, favorite attraction categories, transportation method, etc. Let's welcome Noah.
So, are you too lazy to make a travel plan? Try the trip generator. I'm Noah Zhang, and I am a mentorship student of the BitProject 2022 cohort. My final project is called the Trip Generator. So, let me first introduce myself. So, I'm coming from Nanjing, China, which is a beautiful city in China. And I am currently studying at the University of Southern California as a computer science sophomore. In my daily life, I am really passionate about human-centered technology, project, or research. So I also have a lot of hobbies, like my favorite ones are soccer, photography, and listening to music. A fun fact about me is actually my nickname. It's called Big Face. You may think that my face is not big. Yes, you're right. I don't think so as well. But my primary school classmates just call me this name. I don't know why, and it continues until today. That's pretty funny. Okay, let me just go on to back on the topic of project. So the background and the motivation for my project is actually that people always love to travel. However, when you go on a travel, just imagine you go on a trip. After you go on a 10-hour flight or train, you just feel really tired. And when you get to the hotel, you don't want to make a plan for the trip afterwards. So at this time, you need a convenient tool to generate a trip for you. Or there's another scenario. When you visit some really famous attractions, you may always feel that, oh, there's so many tourists. I don't want to stay here anymore. You just want to go to a quiet attraction that is not that famous, but also worth a visit. So at this time, you want a tool to generate your unique trip. However, Google cannot do that. So when you want a convenient tool to generate a unique trip, using such idea, I developed the trip generator. So now I want to give you a demo of my website. As you can see, this is a pretty simple user interface. It has a title and a slogan, "Too lazy to make a travel plan." Well, I'm lazy to make a travel plan, actually. It's designed for me. Just joking. Okay, so, and then there's a form for the users to fill in some of their inputs. There are in total 4 inputs. The first one is your location. You can enter a city you want to explore or the exact address that you are located at, such as your hotel. Like right now, I'm located in the New York City, so I'm just typing in New York. This will kind of interpret it as you're in the center of New York, your location exactly at that point. And then there's the input of category. Users can choose your favorite tourist attraction type. And I made like, there are actually 6. And the first one is just the most famous ones. And the others are cultural, natural, sports, leisure, and political. All these categories, they all include some other detailed types. Like for the cultural category, it includes the museum, art gallery, the university, the libraries, and so on. For natural, you can see a lot of other types like national park, zoo, aquarium, and also some normal parks. And for the sport, you can search for the stadium type, the field type, or even some like small park type. For leisure, we all know that there is the amusement park type, the theater type, and some cinema type and other like leisure and amusement places that we want to go to. And for political, there includes the city hall, the memorial, and so on. So each category includes a lot of different types. And when you choose one, it will generate a random trip for you inside these types. So for transportation input, you can input your transportation mode. We suggest the cars because it is kind of the most efficient way for you to travel in the US or the world because it's really flexible. But there are also other options like the public transportation, your legs, and the bicycles. So you can just choose one of them. I will currently just choose the cars. And for the last input, it is the quantity. So this indicates that how many attractions that you want to visit for today, for this day. We limit this to 1 to 5 because we know that even if we're on a car, we cannot just visit so many places. So we just have a limit. For now, I just want to choose 3. So I want to choose natural as category, and let's go on the demo. Let's generate my trip. I'll click on it, it's loading. Yeah, we need to wait for like some time before the result comes out. Yes, as you can see, our trip is generated. This trip includes 5 points, and the starting location and ending location will be the location that you input. This whole trip is the shortest route when you start and end with this location and goes through these 3 destinations. It is already optimized. And we can see there are like this aquarium, this beach, and another beach. I think I will just go to, I don't know these places. I may go to like after this recording. And these links beside between different destinations, when we click on it, it will be directed to the Google map. And you can notice that the inputs are already the destinations that you have on the trip generator. So it's really convenient to use as really generating some special places that we cannot search for on Google. So that's pretty much the demo. I want to continue talk about my project idea and also other technologies that I used. So as you can see, my project goal is to just build a website that could randomly generate a one-day trip plan. Based on your user's inputs, such as the location and categories, this trip will include some unique attractions with the shortest route for the day. In the trip generation flowchart below, you can see that from the website, it will get the user's input and transfer to the Azure function. And then Azure functions will select some data and transfer them to the 2 APIs that I developed. The first one is Google Places API, and the second is the route calculation API. They together formed the final tourist attraction data, which will be output to the website UI and displayed to the user. So this is my project development timeline. It mainly covers 6 weeks for the serverless camp. From week 4, I formed the idea until last week, which is week 9, where I just formed the website Frontend UI. So I want to first talk about the Google Places API that I developed. For this API, I used the technology of Azure Functions, Node.js, and Google Places API. For Google Places API specifically, I used the 2 functions, find places and nearby search. In the flowchart below, you can see that the website.js file would get the user input into this API, and then the API will use the user location to get the places latitude and longitude through the Google API. And then this places information combined with the user's favorite attraction categories will be imported into the Google's nearby search API. And it will return then the attraction array, which is the attractions near the user's location. After then, the attraction array will be filtered and shuffled and finally output back to the JS file. On the right, there's a screenshot of this attraction, how this attraction array look like. You can see it's the array of the St. James Catholic Cathedral and based in Orlando. And then I want to talk about this route calculation API. In this API, I use the technology of almost the same as the Google Places API. I use the Azure function, Node.js, and the only difference is that I use the traveling salesman algorithm, which is a famous algorithm for the route calculation. The challenge that I encounter in this API is that my original idea is to use external API called the map toolkit. However, that didn't work out because this map toolkit only returns the shortest route between 2 different destinations. However, what I want is that no matter how many destinations are there in between the starting and ending point, it will always optimize me a route that is shortest passing through these destinations. So I developed my algorithm based on the traveling salesman problem. And then using this algorithm, I was able to get this tour or route array and output to the JS file. As you can see on the right, there's a screenshot of this example output. This tour's numbers are just representing the index of each point or destination. So at last, I just developed the website frontend. From left to right, you can see the difference. I use the CSS to stylize my frontend and deploy it onto the Azure Static Web App. During this project, I encountered so many challenges. And I want to say the most challenging three are these three. The first one is the infinite loop inside the Google Places API. For this, I drew a flowchart. It's pretty much the same as before. However, I added part of the steps during the filter and shuffle function processing of the Google Places API. Inside that step, I used the random number generator originally, and in order to generate a random attraction. Normally it will work well. However, when the Google's nearby search API isn't working pretty well, like if some places doesn't have many political tourist attractions, then it may stuck. This step of randomizing may stuck into a infinite loop, and at this time, people and users cannot get any output. So this problem really stuck me for a while, for some days. And then I just debugged together with my mentor, Anthony Chu. He patiently just guided me through the VS Code debugging series. And then we found the problem happening inside this loop. So later we just removed the loop and replace it with a shuffle directly onto the array. So that avoids any problem with the loop. And another challenge is the original external root APIs problem, which I have already discussed. And the last most challenging one is the issues with GitHub and Azure. So this is actually the last step of my whole project, where I deployed my website onto the Azure Static Web App. However, after deploying onto the web app, I found that the functions inside the API are not working well anymore. They always return a 500 error. So I just I just think about start over all the functions, deploy it to a new Azure Function app. Inside the app, I was able to look at the log string, which I cannot in the Static Web App. So after seeing and peeking through all the console log inside the function app log string, I finally found the problem with node fetch, and I fixed it by reloading and starting over the web app again. But finally, it solved all the problem. So these challenges are really confusing and challenging in a glance. However, after being patient about them and starting over and getting guidance from mentors, all problems are solved. And I think the last part is the upcoming features. I may want to add so many features in the future, including adding some pictures and introductions for each output attraction, and also adding interactive features like logging, saved attraction, and personalizing the tool trip, and so on. There are so many features that I want to add, and if you have any ideas, please tell me and email me. Last but not least, I want to thank you, Bit Project team. I want to thank my mentor, Anthony Chu, who helped me so much in producing such a project and giving me a lot of guidance and experience in the industry. And I want to thank Shreya, Beatrix for hosting such a great camp. And I want to thank Ganning and Emily, who give me so much inspiration during the assignment and the project. I also want to thank other camp students and instructors like Melody, Jelling, John, Christian, who helped me a lot on Piazza and Discord. We also cooperated on some cool challenges. I think the summer of the Serverless camp is not an end, but a starting point. And I want to thank you all for listening to my presentation. Thank you so much.
Thanks, Noah, for showcasing the project and for the shout out. I love the idea of random generator of day trip plan, especially for me, who is sometimes overwhelmed with the travel information out there. Okay, the next talk will be When to Leave for an Event project by Sania Kaja. Sania Kaja is a rising sophomore who is studying computer science at the University of Illinois at Chicago. Sania created a web page where a user can put in an event's date, time, and location in a form, store it, and be notified a few minutes in advance. So let's welcome Sania.
Hello, today I will be talking about a project I created over the past month called When to Leave. This is a project that tells a user when to leave for an event. Before I get started, I wanted to introduce myself. My name is Sania Kaja, and I'm a sophomore studying computer science at the University of Illinois at Chicago. Outside of class, I like learning new topics and skills. I also like trying out new things, whether that be activities or food. Now I'll tell you a little about the project. My project idea stemmed from some personal experiences. I drive almost daily to college and tend to have a lot of family events. Since I go out so much and I want to reach on time, I usually have to think when to leave and constantly check the traffic. I am sure that there are others who have a busy schedule and would love to be relieved from having to think about when to leave. This then has made me think how it would be nice to have a notification that tells me when to leave. In order to solve the problem I had identified, I decided to create a product where the user will be notified when to leave for an event based on some information that the user provides. The user is asked for some key information which is stored in a database and later used in order to help them determine when to notify the user to leave. These are some screenshots so you can get a better idea of how it all looks. On the left, there's a picture of my form page with the following required fields: email, current location, event address, event date and time, parking time, and notification time. On the top right is an example of how the data is stored in Cosmos DB and how that looks. You can see that all the fields in the form exist in the database. The bottom right shows an example of how the email that I send to the user looks. So what does the user have to do? All the user has to do is fill out the form properly for the next upcoming event and submit, and they're good to go. The rest is done behind the scenes, and then at some point the user is notified when to leave in the email they had provided. They can update the event at any time by putting in the same email address they had initially put. So now I'll show you the code in action. So first you can see an email. I'm just going to use any email, one of my personal emails. And as you can see, once I clicked on a field, the current location shows up. After that, I can put my event address, which I'm just going to put my college's address. And then I'm just going to put an event date and time, like when do I want to reach? So let's just say that I want to reach at 2 and I want to reach there today on August 12th. Amount of time to leave for parking. So let's just say it takes me about 10 minutes to park and walk to where I want to walk. And I want to be notified 30 minutes before in advance so that I can get ready and maybe eat before I leave. So now I'm just going to submit this form, but pretend that I forgot to fill out one of these fields. If I try to submit it, it'll say that it's required and I have to fill out all these fields before I can submit. So now that I'll fill this out, and once I submit, you'll see, oh, okay, it's submitted successfully. So now we'll be able to see this information reflected in the database, which in this case is Cosmos DB. So if I look at my items, I can look for the email I put, and you can see that you can see Sania Z. Kaja, that was the email that I put, my current location, the date and time of when I wanted to reach, which was August 12th at 2, how much parking time I wanted, and the user notification time. Now, let's say that my function will check every 5 minutes to see, oh, should I be notified or not? And this is an example of a way that the user is notified. So what happens is when they're notified, it'll say time to leave for your event soon. And it'll tell what time you want to leave, which in this case had been on August 3rd at 11:37. And to reach what event, and in this case, it had been an event that was at 2:30. So that just in case you don't remember what event you wanted to be notified about, you have the date and time. So let's look at my code now. So as you can see, this is my HTML page. This is pretty simple. I'm using a mixture of Bootstrap and my own CSS style over here to create my HTML form, which I showed you over here. Then I have some code. This was how I got the current location. And these were all the fields that the user filled out and submitted. I then linked this to another JavaScript, which is this page. So this page is what is going to send my data from my HTML page to my Azure function. So first I get the form, and once I get the form, I get all the values from the form. After that, I make a post request to my Azure function, and it'll send it as JSON data. And then after it sends it to my Azure function, all the data, I then clear everything and show the success status. So now this is my Azure function. So for this Azure function is my HTML trigger function. And as you can see, I have different functions here that run. So this is just creating to make sure that the database is actually there. And this is to create a new document if needed. This gets all the items in my database, and this will update an item if it already exists in the database. Now, this is like my main function. So I get the data that had been sent as a post request. I use Azure Maps in order to get the latitude and longitude of the event address that the user had put in over here. Then, after that, I send all of this data. I store all of this data in a document, and then I send it to get items, and I check, I check if there's any items with that username, that user email, and if there is, then I either create a new document, which is a new item, or I just update an existing item. This is my timer trigger Azure function. So this is still dealing with the database. This gets all the items from the database. And based on that, I go through every item in the database that I got and call another function called getLeaveTime. In this getLeaveTime, this is where I will do all my calculations. So I first will check what the current date and time is. I'll get that. I get the traffic info from Azure Maps, from an API by using a GET request. And then these are some of my calculations. So I have parking time, notification time, how much time is needed before when I have to leave. And this is to notify the user. So it checks, okay, is the requirement met? Does the user need to be notified? If they do, then I will call another function that'll tell them to leave. And this function is my email function to send the email to the user as a notification. This is pretty simple. I send it from my personal email to another email, and that is about it. So we'll go back to my my presentation. So this is the demo. That was the demo of my project and some of the code. So what technologies did I use? I needed multiple different technologies in order to code my project and get it to work. I used VS Code as my coding platform and GitHub to store my code. Azure Static Web Pages was used to host my website. HTML, CSS, and Bootstrap were used in order to create and style my front-end form. JavaScript was used to send JSON string data to my Azure functions and then stored in Cosmos DB. The data was also read from Cosmos DB by using SQL commands. Node.js let me use fetch commands for my API, and Postman was used to test my API calls. Azure Maps geolocation was used to convert the event address into a latitude and longitude coordinate, and for traffic information too. Once a notification needed to be sent, I used Twilio SendGrid to send the email for me. So this is a more visual representation of how everything works together. As you can see, the front end consisted of HTML, CSS, JavaScript, and Azure Static Web Pages. JSON string data is sent to the HTTP trigger Azure function when the submit button is clicked and the user's location is also sent. This Azure function is then used to upload the event data to Cosmos DB. The Azure function and Azure Maps geolocation API was used to convert the event address into latitude and longitude coordinates. Node.js was used for the API calls. The Azure timer trigger function was triggered every 5 minutes and would use Azure Maps traffic API data. The current location and the event location was used in Azure Maps traffic API in order to get the traffic time. I used traffic time, notification time, parking time, event date and time, and current date and time in order to determine whether to send the user a notification. Once it was determined that the user needed to be notified what time to leave, SendGrid was used to send the user an email. I faced a few challenges while working on this project. There were many different APIs that I had to use, and each one worked differently. I was not very familiar with how to read documentation and change the code in a way that would work for my needs. While trying to make changes to existing code in the documentation, I sometimes had the wrong idea on how it all worked, which sometimes then led to errors. One example was when I wanted to query particular data based on the user's email address. I had the correct SQL command, but I did not have the parameters for it to know that I did not mean the word email and meant the variable email. This is shown in the image above on the left side. There were times when I knew how to make each part of my project work separately, but then was unsure how to combine it together. This is especially true when I wanted to work with my front-end form and then send that data to Cosmos DB and have the proper format, which I then figure out I have to send as a post request. I also had just some general logic and syntax errors. An example was that I thought that the submit button will allow the required fields to be required, but I actually had to submit the form in order for the fields to be required. I sometimes was also not sure what settings and configurations to add and where to add them to make sure my code would work both locally and also not locally. An example would be that when I deployed my code to be used externally, it was not catching the correct time zone, so my email event times were showing up wrong. I then had to configure it to my Azure function in order for it to work. A lot of these issues I was able to deal with by researching, asking my mentor for help, and also pair programming with my mentor. There are always ways to make a product better, and I have a few ideas that could make when to leave project better. First, I want the user to be able to add multiple events. Currently, the user can only add one event and update that one event. Allowing for the addition of multiple events would make it easier for the user, since they would not have to think about updating the event after they've been notified. One way to incorporate multiple events is by using an external calendar, such as Google Calendar. This also would allow the user to have less to keep track of. Another feature I wanted to add was allowing weather data to be used. This could help make my calculations more accurate. So for example, if it was snowing, I would tell the user to leave a little earlier so that it would allow the user to have more time just in case they have to clean their car or anything like that. I also wanted to allow the user to have an account where they can view and update upcoming events and see what preferences they had set. Another potential feature that could be added is user feedback and allowing them to tell me how accurate the leave time was. This would allow me to make further improvements upon my calculations. The last feature I would like to add is allowing for other modes of transportation, such as commuting by train, instead of just commuting by car. I learned a lot throughout this experience. I learned to work with multiple different APIs and be comfortable with not knowing everything off the bat. Not knowing everything meant I learned to ask questions, research, and look up anything I wanted to know about. I learned that there were so many products to help with the coding process. One such example was Azure and the variety of services they provide. Creating this project from scratch meant learning a lot of new technologies and skills, and understanding how the front end and back end work together. This made me dive into the unknown, and I felt like I learned a lot throughout the process. I wanted to give special thanks to Bit Project and my mentor, John Kilmister, for this wonderful opportunity and learning experience they provided. I truly grew a lot from this experience and have become more confident in my abilities. I hope to be able to further expand upon this knowledge and utilize the skills learned in the future. Thank you for your time.
Thank you, Sania, for your hard work this summer. That's amazing to get even notification beforehand and get the current traffic data to leave for the event. So the next talk is Saving Money at the Grocery Store with Serverless by Matthew Morales. So Matthew is a rising sophomore at the University of Utah studying computer science. He will be presenting the app as a simple tool to help save money on food by planning shopping trips ahead of time. So welcome, Matthew.
Hi everyone, today I'll be presenting on my project Grocery Planner, which I've been working on over the summer for the Bit Project Serverless Camp. So before I get into my project, my name is Matthew Morales. I'm a sophomore at the University of Utah. I'm pursuing a bachelor's degree in computer science and a minor in Chinese language. When it comes to technology, I especially love to learn about game development, computer graphics, and electronics. So when I first began to brainstorm what I could do for my final project, I thought about the things that I do on a regular basis. My mentor suggested for my project it would be helpful to consider what kind of project would be most useful to me personally. Buying food is a necessity, obviously, but it can get really expensive. This is especially true for eating out. Cooking meals at home is a great way to save money, but that comes with a whole new set of challenges. Not only is it difficult to find new recipes, it can be hard to get the necessary ingredients. There are so many options at the grocery store that prices can start to add up really quickly. Even buying mostly generic brands or shopping at cheaper stores, it's still easy to end up buying things you don't need simply because they look interesting. As a college student living on my own for the first time this past year, I've noticed that planning meals and groceries ahead of time is incredibly useful for avoiding these pitfalls. It's a lot easier to avoid buying unnecessary items when I have a list of exactly what I need to buy. When I don't have a list, I'm a lot more likely to forget items, which then requires me to walk all the way back to the grocery store later in the week just to pick up a few items. I'm also much more likely to buy more than I need or spend a lot more money on junk food and snacks. So creating grocery lists ahead of time leads to healthier eating habits, lower spending, and less wasted food. But it can also take a lot of time, and it's often difficult to find motivation to create these lists without the proper tools. When planning a week's meals, I would often use a variety of different sources. I would look at recipe websites and list recipes in my Notes app, at the same time keeping track of all the different ingredients I would need. Then, in order to figure out how much this would cost ahead of time, I would need to look up all this information in my grocery store's website. Throughout this process, there was a lot of wasted time and tedious preparation. In addition, I would often be frustrated when certain grocery apps didn't have some small feature that I wanted or didn't quite work properly all the time. So I wanted to make a way to make this process easier. My solution was Grocery Planner. With the app, I can manage my grocery list and check prices all in one place. First, you pick a grocery store, then you can select products you will need for the week, and then finally store it all in one place and make it available from any device. Let's show you a demo. So when you first open the app, you're greeted with this Login with Kroger page. The reason you have to log in with a Kroger account is because in order to get all of the price and availability information, the app uses the Kroger Public API to get that information. So after I click this button, I'll be taken to the Kroger login page. And once I log in, I'll see a page just like this. So on the left, I have my grocery list. This displays all of the items that I've added previously. And then on the right, we have this Add Items section. So on the left here, we have all of the items that you might need for sandwiches. But let's say I wanted to add another protein. So let's look up ham. So it'll show me a bunch of different options, including things like the product size as well as the price, including the promo price if it's available. So let's pick this one because it's on sale. When I click it, it gets added to the list over here. Also, to note, I don't need to put in the exact product in title in order for it to give me options. I can just type in a search term and it will bring up anything that matches that query. I can also remove items if I decide I don't want them after all. Like let's say I just wanted ham on the sandwich. I can click there. And then once I'm happy with the list, I can click Save. And then it will let me know that it was saved correctly. And now if I reload the page, my grocery list will still be there. I can also clear the list when I'm done. And then finally, up here at the top, we have this location selection menu. So right now it's telling me what my current location is here, but I can also change it. I can do this by clicking the change button and then looking up my location via postal code. So right here I've searched 84044, which is the zip code in Salt Lake City, and I can change my location to whichever Kroger location I'd like. So that's it for the demo. Going back to the presentation, this is a flowchart I designed in the early stages of my project. It ended up getting a bit complicated, as in order to use the Kroger API, I would need to authenticate a user with OAuth. What this essentially means is that the application requires users to sign into a Kroger account and grant the application the necessary permissions before it can get the information it needs. So the first thing that happens in the app is the user is directed to Kroger's website to log in, as we saw. Once they do, the application is granted the authorization code, and then this authorization code is sent to the Kroger OAuth server, or first it's sent to an Azure function, which then sends that authorization token to the Kroger OAuth server, and then an access token is returned. This access token can then be handed back to the browser where it is saved, and the user is redirected to the main page of the application. So then whenever information is needed from the Kroger API, a request is made on the browser to the corresponding Azure function, including this saved access token. That Azure function then makes a request to the Kroger API and then returns the necessary data. Finally, when a user is ready to save their list, a request is made to the save list function. This is not pictured in the chart, but the save list function also makes a request to the Kroger API to get the user's profile ID. So that way we can associate lists with a given user account. Finally, the grocery list, including the selected location, user ID, and item information, is saved to the Cosmos DB database. In order to make this project, I needed some specific tech skills. In order to create the UI that I would actually interact with, I needed a knowledge of HTML, CSS, and JavaScript. And I would also need some source of product information. Like I've already said, I chose to use the Kroger public API for this because it would have most of the information for most of the grocery stores near me, as well as many other grocery stores in the US. And we learned over the summer how simple Azure Functions and Cosmos DB are to use, so I chose that for the back end of my project. The project also came with some specific challenges. The first was, as I mentioned, OAuth authentication, as this was something that I've been confused by in the past. And it also required reading some specific API documentation to the Kroger API, which was challenging at times to understand how each endpoint was intended to work. But ultimately, I was able to figure things out with the help of my mentor. Also, early in the project, I decided to stick with basic JavaScript, CSS, and HTML rather than utilizing a front-end framework. I chose not to use it because I thought the project scope was small enough and that I could potentially benefit from learning how to do this without a framework. Though working through these challenges, I've come up with a couple of key takeaways. And the first one is don't reinvent the wheel. As I continued developing, I began realizing that a front-end framework would have saved me quite a bit of time and would have probably resulted in much cleaner code. So although I did learn from making the front end in this way, I also ended up making a lot of compromises due to time constraints. I considered switching to a framework midway through the project, but my mentor advised against this as I was running out of time and would have needed to rewrite a large portion of the project code. So ultimately, this was the correct decision as I may not have been able to finish in time had I switched. The number 2 takeaway was to keep the scope manageable. It became clear early on that the scope I had originally planned would be way too complex for the time given. I never would have finished in time if I just tried to stick with my original plan. So I think it's important to recognize what is absolutely necessary and what is optional in a web application so that you know where to focus your time and energy. So the biggest feature I had in my initial plans but didn't make it into the project was a recipe feature. This would have been a way to organize recipes in addition to grocery lists to aid in planning. I think this would have been a great way to save even more time as it would allow users to save recipes and easily import the necessary ingredients to their shopping lists. So in the future, there's a ton of different ways this could be improved to streamline the process of planning groceries. For example, the app could recommend saved recipes based on what ingredients are already in the user's shopping cart, or even integrate with a recipe API to aid in the discovery of new recipes. However, before any of that can be done, I would likely need to migrate to a front-end framework like React. This app has a lot of user interaction and could definitely benefit from it. There are also a few more limitations to the app in its current state that I would like to address in the future. For example, it's currently not usable for grocery stores not owned by Kroger. So in the future, I could look up more grocery chains with APIs to make the app even more useful. But overall, I've learned so much over the past few weeks, and I feel a lot more confident moving forward with how to organize my personal projects, and I'm excited to see where else I can apply what I've learned about serverless technology. Thank you to everyone who's been watching the stream, and thank you to the Bit Project team and my mentor, Adam Bashir, for all their help.
Okay, thanks Matthew for your hard work. I love buying grocery, but I'm bad at saving money to buy food, so I definitely need this app. So the next talk is Serverless shipped on day 1 with Luke Hedger. So Luke is a lead engineer at the Lego Group, AWS community builder, and serverless superfan. In this talk, he will show how we can snap together a small set of tools to quickly and simply get your serverless application running in the AWS cloud. So welcome, Luke.
Hello and welcome to the talk. It's great to be here at Serverless Days to get the opportunity to speak to you all. My name is Luke. I'm an engineer at the Lego Group, and I'm also an AWS community builder. I want to talk to you today about shipping on day one and every day after that. So let's get started. So firstly, what makes serverless different? What makes shipping serverless apps different? I believe the main thing that makes serverless apps unique are our use of managed services. And what we mean by managed services are things like AWS Event Bridge for event buses, step functions for workflows, SQS for message queues, things like that. Serverless apps are made up of lots of different pieces, and they're distributed sometimes across different regions and availability zones. The code that we write, the business logic that goes into Lambda functions, they often make up just a small part of an overall serverless application. So because of that, serverless apps must be deployed to the cloud and operated under real traffic to be best understood. We need to understand things like, how does my Lambda to DynamoDB integration scale? Do any requests get throttled? Are there any bottlenecks? What sort of service limits are we likely to hit? It's not until we ship our app that we begin to understand its behavior. And that's why we need to make shipping a habit. We do that by setting up our serverless delivery pipeline on day one of our project, using that pipeline on that first day and every day after that. We make shipping our serverless app a habit. And in doing that, we'll release the full potential of serverless and ensure that we build the best application possible for our users. So today, that's pretty much the end of the talk part. We're going to get into a nice live demo. And this is what we're going to be building today. It's possibly the simplest serverless application you can build. We're going to have an API gateway endpoint with a Lambda function behind it, and that Lambda function is just going to write something to a DynamoDB table. We're going to use the AWS CDK for our infrastructure as code, and we're also going to use a bit of GitHub Actions for the delivery pipeline. And when we talk about shipping our serverless application, what we're really talking about is two stages there. There's the kind of local part where we write our code, we want to deploy it to the cloud, run it, and get feedback as to whether that code is actually working. And we want a nice, fast iteration feedback loop there. Once we're satisfied, what we would usually do is push that code up to GitHub, and that starts the kind of the remote part of our delivery pipeline, where the GitHub Actions workflow will run and we'll deploy that code, that serverless application, to our production environment for our users to use. So those are the two parts of the delivery pipeline: that local part where we're making code, pushing to a dev environment, and the remote part where CI/CD pipeline takes over and deploys to production. So let's get into our demo. I will just change the screen. So let's get into our demo. I will just change the screen. And there we go. Okay, so we're starting with a pretty much blank project. all we have in there is our GitHub Actions workflow, which we'll take a look at in a second. But other than that, we don't have any code to begin with here. So what we need to do first is initialize a new CDK app. And we do that with this command. So we're just saying to the CDK that we want a brand new app, and we're going to use TypeScript for this example. There we go. That's going to give us all the files and directories we need for a very basic CDK app. Let that run through. We're also going to need a few dependencies. So we're going to go ahead and install those first. First, we'll add our dev dependencies. We know we're going to need ES-build for bundling our TypeScript code. And we're also going to need the AWS lambda type definitions for TypeScript. So we go ahead and install those. And we know we're going to need a couple of runtime dependencies, including the AWS SDK for DynamoDB. Of course, DynamoDB was in our stack there, so we know we're going to need that for performing some operations. And we're also going to have a little library just to help us generate some IDs. So we'll go ahead and install those as well. Now, what we need to do is jump into our stack. So our CDK stack is in this lib directory. And this is what is where we're going to define all of our resources. So the API gateway endpoint, the lambda function, and the DynamoDB table that we saw in our architecture diagram earlier. So CDK gives you a little bit of a helping hand to begin with. So we're going to go ahead and define our resources. So we get these from this AWS CDK lib package, and each AWS service kind of comes with its own set of resources. So we're going to go ahead and grab the table from DynamoDB. We're going to get a function from something called lambda node.js, which just gives us a nice wrapper around a lambda function and uses ES-build to bundle our TypeScript and our dependencies into a nice single JavaScript file that we push up to AWS, and that becomes our lambda function. We're also going to grab the API gateway. So let's go ahead and do that. And CDK lib API. Where are we? There we go. Oops. And we're going to need the lambda REST API. We'll grab from API gateway, and that just gives us a nice wrapper around API gateway that integrates directly with our lambda function. So we will start by creating those resources. So we go with our table first. And really what we're trying to demonstrate here is how quickly we can kind of get up and running with a serverless application, but also how quickly we can actually begin to iterate on that serverless application, and how quickly we can ship that service application to the cloud and get it in front of our users. So here we go with our table. We just need to add a little bit of configuration. DynamoDB comes with this concept of a partition key. So we need to just give it a name. We can call it ID. And it also takes a type. And that type needs to be an attribute type. And it's going to be a string. So there's our DynamoDB table. That's all we need there. we'll go ahead and create our handler function. So we need our Node.js function there. We'll go ahead and call that something similar. So we'll leave. Yeah. So the thing you need for your Lambda function is now an actual function. So we'll go ahead and create a new directory, which CDK doesn't give us. We'll just call it source, and we'll go ahead and create a new file in there called handler.ts. Now we need to tell the CDK where our handler function is. So let's go ahead and do that. So we can use path to help us here. Join. Oops. And go ahead and join their name. Source and TS should be all we need there. Actually, we just okay, and then we'll go ahead and create our API as well. So new lambda REST API. Again, we'll just call that something very similar. And all that takes is a handler there. Okay, so we're all good there. So that's going to get us that's going to give us our basic stack. Now, if we go back and add some code to our handler, because at the moment it is completely blank. Now, CDK is expecting an export called handler, so we'll go ahead and give that. It's going to be an asynchronous function, and we can just go ahead and maybe do a little console log. Hello, service days. And as it's an API, gateway handler would also just need to return an API response. So we're going to say status code is 200, and the body, let's go ahead and say hello serverless days again. So we have our stack and we have our Lambda function. So what we can do now is go ahead and run the CDK watch mode. Now this is a super powerful tool that essentially allows us to deploy our application to the AWS cloud. So it's running fully in the cloud at that point. But the CDK watch mode allows us to iterate very quickly on our Lambda function code. So on the first time you run CDK watch, it will deploy your full application. If you then update your Lambda function code, it will then, on subsequent deploys, it will just deploy the changes to that function. So it makes that feedback loop much quicker. So we'll go ahead and run CDK watch. We'll notice that that is now triggering a CDK deploy. It's going to go up to AWS. It's now running the necessary CloudFormation operations to create our resources. And when that's done, it should give us the URL to our API. And we can go ahead and grab that and make a request to check that everything is working correctly. So we'll just let these CloudFormation updates go through. As I said, with the watch mode, that initial deploy is slightly longer because it's deploying your entire stack, which in our case is still pretty small. And then subsequent deploys, we should see, are pretty quick. So there we go. It's all finished. It's given us our API gateway URL. So we should be able to now go to another terminal and make a curl request to that endpoint and see what it gives us. Okay, so we get the 200 status code that we were expecting, and we also get a nice polite message saying hello serverless days. Now what you'll notice that just tick through here on the left hand side where we're running our CDK watch command are some logs. Now these logs are actually coming live from CloudWatch logs. We see the log that we made there, info hello serverless days. And to show the quick deployment, what we can do is go back and change that log, hit save on the file. It's gonna trigger a fresh deploy up to AWS, but it should be a lot quicker because we just changed that single line. There we go, the deployment's done. If we were to hit that API again, we'll receive the same 200 and the same response, hello serverless days. But what we should see is there's a slight delay on the logs coming down from CloudWatch, but not too much. And there we go, we see our updated log. So I mean, that's just a simple example of logging, but you can imagine how quick it is to iterate on your function code using CDK watch mode. Now, if we go back to our architecture, of course, what we wanted to do from our lambda function was put something into our DynamoDB table. So firstly, what we have to do is actually give our table a name because I forgot to do that. So we'll just call that the serverless ship table. And there we go. Make that nice and readable. Oops. And we need to tell our lambda function the name of our table, otherwise it won't know where to put new items. So we go ahead and create an environment variable called table name, and we're just going to go and grab the table name from the CDK construct there for our table. That's going to be available to our lambda function. We'll hit return on that. It's going to trigger a fresh deploy. Now there's a few things we're going to need in here. We're first going to need a type definition from our AWS lambda type. So we go ahead and grab that. We need to know about API gateway event. There it is. And we're going to pass the event payload in there. Now, what we need next are some things from our DynamoDB SDK. So we're going to go ahead and grab those. We need the DynamoDB client. Any SDK operations always center around a client, which is essentially your connection to the service, and a command. So in our case, we want the put item command, and you send those commands to the client. And we're also going to need our little ID generation library in there as well. Now we can go ahead and remove our log. What we'll do is we'll generate we'll go ahead and generate our ID using the nano ID library. And what we also need to do is create our DynamoDB client. Now we do that outside of the handler. So that happens in the init phase of the Lambda execution, and is only done once for the entirety of that that Lambda instance, and that saves time on subsequent implications. So here we go, DynamoDB client, and we need to give it a region which we can get from the default environment variables. It's just going to be the region that the Lambda function is running in. Now we need our command, so we'll call it put item command. Go ahead and create a new put item command that takes some options. Firstly, the item itself, which in our case is just going to be a single field called ID, which is a string. This is just a special way of defining DynamoDB values. And then we'll give our table name, which we're going to get from our environment variables, and that's table name. So that is our command. Now what we need to do is go ahead and send that command. We wrap that in a try catch block, so that any errors in sending that command are caught, and we can handle those separately. The AWS SDK uses promises, so we can go ahead and use the async await pattern to send this command. Use the send method, and you just give it your the command that we made earlier. Let's go ahead and add a little console log to say we put the item successfully, which table it went to. Okay, and let's handle the error. We will log the error, so we can see that in our terminal from CloudWatch logs, and we'll go ahead and return a status code of 500 if we caught an error. Okay, so we hit save on that. Now that's going to get deployed up to AWS. There we go. So now let's give it a go and hit our endpoint again. See what we get. Okay, so we got a different status code this time. We got a 500. That means that our Lambda function has encountered an error. And here we go. We've got some useful looking logs. So we've logged out that error. And what we can see here is it's an access denied exception. And if you look a little bit closer, what it's saying is that our Lambda function's IAM role is not authorized to perform the DynamoDB put item action onto our serverless ship table. It basically doesn't have permissions. And that's fine. That's good, because actually we never gave our Lambda function permission to write to our DynamoDB table. So we need to go back to our CDK stack, and we say give our Lambda function permission to write data to our DynamoDB. And it's as easy as that. No custom IAM policies, least privilege policy generated out of the box from these CDK helper methods. We'll go ahead and save that. Get that deployed. It'll take a little bit longer because it's an actual infrastructure deployment. And once that's gone through, we will go ahead and try our API again. Let's just wait for that to go through. there. Okay, there we go. Finally got there. So let's go ahead and hit our endpoint again, and we're hoping we get 200 now. We do, we get 200. Still got our nice hello serverless days message. Now let's see what our log says from CloudWatch. And there we go. We've got that info log. It's put item, given us the automatically generated ID, and there's our table name as expected. So that has worked. Now, staying in VS Code, what we can do is actually check that item does indeed exist in DynamoDB, and our logs aren't lying to us. There's a handy VS Code extension called Serverless Console. Now, it's got a nice UI to set that up. We'll go ahead to DynamoDB. We'll select our region, find our serverless ship table, and go ahead and add that. And then we get a nice UI to explore all the items in our DynamoDB table. We can scan and query as we could do in the console or the CLI. But in our case, we've only got one item, and there it is, Y3Q, which does indeed map to what we saw in the logs. So we can confirm that item did indeed make it to our DynamoDB table. And we've done that all nicely through VS Code. We've developed the app all through VS Code, and hopefully that seems pretty quick. Nice quick iterations on that, even through that IAM permissions issue. So our work here is done in terms of the local part of our serverless delivery. So what we need to do now is go ahead and push that up to our GitHub repository, and we can test out our GitHub Actions workflow. If we take a quick look at that file, it looks something like this. So this GitHub action is just going to trigger whenever we push to our main branch. It's got a single job called ship, of course. And that does just a couple of things. It configures our credentials for AWS, so we can actually deploy to AWS from the GitHub Actions workflow. It installs the npm dependencies we need, and it's going to go ahead and run CDK deploy, which is kind of similar to our watch mode, but it doesn't just hang there waiting for updates. It just does a deploy to CloudFormation and finishes. So we will go ahead and stop our watch mode here, and we can go ahead and push up to Git. We don't want DS store in there. Okay, everything else looks good. So let's go ahead and add those files. Ship. And we'll push that up. Okay, so if I just change my screen now and can show you the GitHub Actions workflow. Now that has started since we pushed to the main branch. That workflow run is now in progress, and we should shortly see those steps being run. Queued right now. Check GitHub action status. That's really good timing for the demo. So possibly won't be able to show you that working. Great timing. So what we'll do is we'll finish the demo there. I can show you one that ran earlier actually. So here's the workflow running successfully. We can see the configure AWS credentials running there. Well, we can't because it's affecting that as well. And you can see the deploy step ran successfully there. It pushed it up to our AWS account. So let me get back to the slides. Okay. Full screen that again. There we go. Okay, so that was the end of our demo, and actually that is indeed the end of my talk. Hopefully that gave you a flavor of how you can quickly get a serverless application up and running, and more importantly, or just as importantly, how we can get our delivery pipeline up and running simultaneously to building out our application, how we can start using that from day one, and how you could continuously deliver that serverless application through something like GitHub Actions. A copy of that application will be available on GitHub. Hopefully Actions is running by then, and you can go ahead and look at those workflows. If you enjoyed the talk, follow me on Twitter, where I talk about these sorts of topics and other serverless related stuff. Copy of the slides on the QR code there. And thank you so much for listening, and enjoy the rest of the.
Awesome. That's pretty much it for today. Thank you all so much for joining us. And massive thanks to Beatrix Scanning and Misha for helping put this entire event together. How are y'all feeling?
Good.
Yeah, I was just going to say
That
the
went
workshops
well.
and talks were really amazing. So
Yeah, exactly.
great.
Especially loved all of the students, and I'm so glad they got a chance to show off the work that they did. They worked really hard this summer. Beatrix, do you have anything you want to share?
Yes, I would like to express thank you for all of you students from Global Student Community Program, students from Mentorship Program, and also Serverless Hacks participants for joining us this summer and making such a great progress. And also thanks to all mentors to help out the students, answer any questions on Piazza. Yeah, and thanks to Bit Project team members. You guys did awesome this year.
You did too. Ganning, is there anything you want to add?
I just want to say, like, it's been phenomenal seeing like everything come together from how much work we've all put in from every aspect. I know I worked on the website, and Shrey and Misha, y'all work on like the logistics and getting sponsorships and everything. And Beatrix, you're managing social media, and it's just really rewarding getting to see all of it coming together.
It's amazing. And Misha, last but not least, is there anything you want to say?
Yeah, definitely agree with, everything everyone's been saying. But I also just wanted to give a huge shout out and thank you to our sponsors, Microsoft and Courier. We're really grateful that you chose to fund our initiatives. As a direct result, we were able to really expand our serverless camp program this summer. We were able to open it up to everyone who applied, which is something we've never done before. We were able to run our first hackathon and, of course, our second Serverless Days conference. So that really is because of our sponsors. And then I also want to thank our wonderful mentors. We're so grateful to have people like you from the serverless community volunteering their time and effort to help our students. I think, even more than just helping our students, a lot of you gave additional support. You participated in our conference as speakers. You hosted workshops and talks throughout the summer, helped us improve our curriculum, even advised our internal engineering team on projects that we're doing just for Bit projects. So all of that is just something we're so grateful for. And yeah, I just want to say thanks again to all the sponsors and mentors, and we wouldn't be able to do what we do without you guys.
exactly everything that you said. The students, the mentors, the sponsors, we literally are so grateful that you're interested in the work that we're doing and supporting us. We will continue to have a lot more educational opportunities, projects, programs, camps, conferences, everything, as well as opportunities for mentors to get involved as well in the future. So if you're interested, stay tuned. We post about everything that we do on Twitter and Discord, so you can find that information over there. And I hope everyone gets a chance to rest after this really long weekend. And yeah, happy Sunday, everyone. Thanks for joining. Bye.